Hi everyone, welcome back to C Sharp Corner SQL Virtual Conference Day 2. What an amazing day one we have had. We are around close to 20,000 people joining. Day 2 is going to be really more exciting as we have guys joining who will talk about Synapse Analytics, SQL Server 2019, benchmarking with the clouds, team from Redgate, and many Microsoft MVPs. So as the other day, I'm your host, Stephen Simon. I go by the Twitter handle Code with Simon. So if you want to go ahead and take a selfie and drop on Twitter, don't forget to tag at C Sharp Corner and you may also tag me. All right. So I see many people joining us today. Portland DBA, he's joining us from Oregon. Paul Hunter. Hi, Paul. Welcome back again. Good morning. He's joining us from Texas. Ali Anwar, welcome back. We are really excited for day two, first half. Definitely the other day was really exciting. We did 14 sessions and just a quick statistics. We reached close to around 15,000 people. So that was a really exciting day the other day. We are back with day two. So thank you everyone who's joining. Hi, your choice. And good evening from India. Paul, thank you. Hi, thank you for joining once again. Ali, hi, good morning everyone. Definitely, we need some coffee to kick in. Definitely, I don't have coffee here in Asia Pacific. We do more of this tea. So yeah, I need a tea. Bhaskar, welcome back. I see you were very active the other day too. You and Paul Hunter. Definitely another learning day ahead. And okay, so Ali is actually joining us from Dubai. So thank you everyone who has joined us today. So I'll quickly go through and pull up the screen over here so that you guys can actually see the agenda for the day. Okay, so day one was all right, perfect. So day one is done. We are now to day two. If you want to go ahead and check the entire agenda, you can go and check on the website. But in fact, we have also given the agenda for this particular first half of day two in the description, so you can also check that. So starting with at 7:30, we have Dennis. I think we are running a little late by 5 minutes. So a speaker would be joining in just some time. Followed by we'll have a session on SQL Server Intelligent Query Processing. Then we'll have benchmarking in the cloud, performance features in SQL Server and Azure SQL, which would be really interesting to learn about. Then we'll have someone from joining us from Redgate, and Redgate has been a sponsor for our this conference. They have new products coming up, so definitely you want to go ahead and check on their website for all the new things that they are doing. So definitely a go-to platform. And they have recently acquired pass, so I think Redgate would continue SQL Saturdays, and that should be pretty exciting. So modern SQL for better performance will be covered by Kathy. Then we'll have John Morehouse. He's going to talk about improving performance with intelligent query processing, and followed by Tracy. Then we'll have a break, just like other day, a 20 minutes break, but usually it goes by 10 minutes break. Then followed by we'll have a session on rocket scientist perspective on index column selection. I'm really excited for this one on how this session is going to be. Have you ever heard a rocket scientist perspective? That's really interesting. Then we'll have how to use geospatial data in SQL Server, performance improvement in SQL Server 2019, bringing DevOps database. Steve Jonas is again joining us from Redgate team. Then finally, we have Azure SQL database businesses continuity during disaster. And then we'll have the closing note. All right. So before we go ahead and get started with that session, I quickly want to go ahead and tell you about the platform where we also stream. So if you are someone who is joining C Sharp Corner event for the very first time, we do not only virtual conferences, we also do live shows that happens almost every day. I mean, you can see we do so many live shows that it happens 8 days in a week. And in most of the cases, they all happen at 10 a.m. Eastern. So you can see if you go to the link that I have given over here, that is csharpcorner.com/live, or you can just hit csharp.live, you will land on this page. Now I quickly go through this product by the time our speakers joins us. So at the top, you see all the upcoming live shows that are happening. So right now this conference is live. So you can see it's live over here. This is another event. Then we have an event that is on Azure SQL Edge and IoT SQL database. In this live show, we have the products team and the engineering team joining us from the Azure SQL, who's going to talk about the products. And then we have Rock in the Code World. So the top banner is mostly about the upcoming shows, then upcoming episodes for that particular day or the coming days. Followed by we have the popular shows. We have different shows that we run on different days. For instance, now this is sorted by popularity. This one is Rock in the Code World, where our host David McCarter, who is a Microsoft MVP, he invites guests from the .NET background. He has had some really amazing people. So if I just go ahead and check it, you can see he recently had Magnus Martinson, who's a regional director for Microsoft, Kathleen Dollard. He has had Bob Roselman, Jeff Fitz, Rich Lander, Brady Gaster, Mark Brown, Jeremy Lignes, Matt Stodgerson, Woody Zill, Scott Hunter. So everyone who comes from a .NET background, he interviews them over here, and you can just go ahead and check this show. This is a pretty interesting one. Then we also have a growth mindset show that we run on Fridays. Followed by we have very interesting show that is called MVP show. So for those who do not know, C Sharp Corner is a platform for developers and IT professionals. We started back in 1999 by Mahesh, and who then started writing articles, and now it has grown to one of the largest social platform community for developers and IT professionals. We serve over 5 million audiences every month, and in the year 2019, we served over 25 million users in just 1 year. So, on C Sharp Corner, you can go ahead and write some articles. You can Okay, right. Okay, all right. So I think it will take for our speakers to come in some time. So by the time what I'll do is, where did we go? Okay, this one, right? So C Sharp Corner has a program that's called C Sharp Corner MVP, where you can go ahead and write articles on C Sharp Corner platform. So when you do that, that's actually we call it as a community contribution. You can not only write articles, you can also write forums, you can also upload videos, and then we recognize them and give them award, that is C Sharp Corner MVP award. And we also have a show dedicated to it where we bring those MVPs and community leaders and take their interview and talk them about their journey, Thank you, everyone. Hello, everyone. Thanks for the conference. Yeah, definitely. Thank you so much for your time. We really appreciate it. I'm not 100% sure if we'll be able to start with the speaker. Let me go and check in. Okay. All right, so we're having some technical issues. So speaker cannot join, so we'll have to go and see what works best. So I'll take for 10 more minutes, and then we'll go ahead and see how things can be figured out. Then we have a show that's called Ask Me Anything. This is a show that I dedicatedly run, and I really enjoy running this show. We are close to episode number 28, and you can see we have interviewed many community leaders, people from Microsoft, different program managers, and it's an open live show. They come and talk about any particular topic. They sometimes have slides and presentation, but you are just the way you can go ahead and ask questions now in that live show. It's pretty open, and you can go ahead and ask anything to the speaker, and it doesn't have to be a technical. But that is a show that I really like to host it. Apart from that, you can go ahead and check the recent episodes, and you can check all the shows. Then many more shows like Azure AI show, Product Showcase show. And if you're someone who wants to go ahead and check all the past conferences that we have done, if you want to go ahead and have one session, then this link is going to be very beneficial for you. I'm going to drop it and I'll put it on the screen. This link itself. This link is going to be very, very useful for you, as you will find sessions from all the past conferences we have done. Not just the entire conference, you will find one particular session. For instance, the other day we had 14 sessions. So on this platform, if you hit this link, you will find 40 or 50-minute sessions divided. So you can see we have React Virtual Conference, we have Angular Virtual Conference, we have Azure Virtual Conference, we have Women in Tech, Software Architect, and in the same way, if you go ahead and hit this link, next week, we are going to upload all the sessions that we have done in SQL for this SQL Server Virtual Conference, and we will put it over here. So this should be your go-to place if you want to go ahead and watch any session once again. So this is a very handy resource. So what we will do now is, I think, I really apologize as the speaker cannot join us, and I'm really sorry about that. So what we will do is, all right, so let me unshare my screen and remove this. So since we're already at 13 minutes, what I'm going to do is we're going to play the keynote session, as we do not have the keynote uh, speaker for today. So what I'm going to do is I'm going to share the keynote from the other day and make sure that it takes. So we will be back after 22 minutes. Okay, all right, I'm gonna stop it. All right, I'll share it once again. So we will be back after around 22 minutes, and we'll start with the next session. I'm really sorry for that, for we couldn't start the first session of this day. You know, these things happen. The speaker cannot make it because of some technical issues. But stay tuned. We will be back after 20 minutes, and then we will start with the next session, that is on SQL Server 2019 Intelligent Query Processing. So until then, I'm going to leave you with the keynote by Asad Khan.
Thank you all for joining me today. My name is Asad Khan, and I work in Microsoft Azure Data. And I'm responsible for running SQL Server and all the SQL services in Azure. I'm super excited to be here, though I missed the opportunity to have this talk in person. I'm happy to join you online and share the work my team has done and where we are heading. But before we get into that, I want to first acknowledge how difficult this year has been. In the best of cases, these have been trying months for all of us. And in the worst, they have been devastating to some. There is no way to frame the hardship that makes them easier to bear. There is only hope and strong communities like you to help us through. In this day and age, the ultimate tool is data. Over the past 12 months, we have seen organizations undergo digital transformation at breakneck speeds, racing forward to achieve 2 years of transformation in just months. While our global situation may have pushed digital transformation to the forefront, it is community that has made change at the scale and pace we have seen possible. We have come a long way together since we started SQL Server over 30 years ago. Today, 98 of the top 100 Fortune companies run SQL Server. While many organizations still run SQL Server at the heart of their business, they are also adopted new application scenarios and new type of databases, to which I am proud to say that many of the Azure data services are built on the innovation that we continue to do as part of our SQL strategy. At the heart of this strategy, we are extending SQL from edge to the cloud, putting Microsoft SQL Engine, your T-SQL skills, and your favorite tools at the heart of where innovation is happening. We equip you to reimagine the art of what's possible. For example, imagine being able to run your SQL apps with AI capabilities right at the edge of an ARM device for real-time updates, or using SQL to run analytics over your structured and unstructured data stored in HDFS. How much time could you save if you could scale horizontally in the cloud to accommodate your most elastic workloads, or bring the cloud security and scaling capabilities to your on-prem deployments. You can now do all of that and more using SQL anywhere. For the rest of my talk, I would like to focus on the latest enhancements we have made to these 5 SQL-based offerings. And more importantly, show how these enhancements are helping companies in their journey of digital transformation. Azure SQL Edge is our new addition to the family of SQL-based products. It offers the full power of SQL Server at the edge, along with built-in capabilities for streaming, time series, and AI. Let's look at how Azure SQL Edge transformed a 3M manufacturing plant, enabling 3M to fix problems before they occurred. The 3M brand is a familiar household name. It's unusual to find a work desk that doesn't include some of its product, such as Scotch tape and Post-it notes. 3M produces more than 60,000 products in various categories, including the N95, which are instrumental in our fight against COVID. My team partnered with one of the US manufacturing plants and the 3M Corporate Research Lab to improve predictive anomalies. The plant's network connectivity was limited. Therefore, it was difficult to gather and transfer and use that data for predictive maintenance. The team decided to move all the data processing and AI at the edge using Azure SQL Edge. Imagine the full power of SQL Server with added AI and time series capabilities running on tiny edge devices. Azure SQL Edge also resolved the plant's problem of limited network capacity, since most data processing and AI was happening where the data was getting generated. Today, this predictive maintenance lets 3M fix problems before they occur. The quote from Mike, their technology manager, captures it nicely. Azure SQL Edge is a great bridge between traditional processes and the newest AI and compute features in the cloud. This is the type of solution that will drive us towards Industry 4.0. I'm sure you are very familiar with SQL Server and how we continue to advance this data platform. In SQL 2019, we enabled data virtualization, intelligent performance, memory-optimized TempDB, and much more. Big data clusters in SQL 2019 was the first of its kind that removed the chasm that exists between operational stores and analytics platform. It's amazing to see how customers are advancing and modernizing their data environments by taking advantage of these new capabilities. Like this example with Itaú Unibanco. Itaú Unibanco is the largest bank in Brazil and 10th largest bank in the world, operating in finance and insurance industries. Their concern was that their infrastructure would not keep up with their growth, and this would affect their SLAs to the business. I'm sure this is something we can all relate to. A good example is when they had to roll back an operation, it took a long time. On average, it took 4 to 5 hours to do a rollback. And sometimes that
All right, everyone. So we are back. So I have the speakers with me behind the scenes. I'm really sorry for all this trouble. These technical issues, they always happen when you go virtually. So we'll go ahead and invite our next speaker, Dennis Torres, who's going to talk about why Synapse Analytics is beyond Azure SQL Data Warehouse. It's going to be really interesting sessions. So let's, without any further ado, let me go ahead and invite our speaker. Hi, Dennis. Welcome to SQL Server Virtual
Hello,
Conference.
Simon. Thank you very much for the introduction.
Mhm. I love
Uh,
your background. Where are you inside? Are you in the spaceship?
oh, yeah, ISS. Great.
All right, Dennis. Thank you so much for your time. We really appreciate it for all that you do for the community. You can go ahead and start to share your screen, and then I'll add it in the stream.
Okay, let's go sharing the screen now.
All right. So I have it with me.
So, first of all, sorry about the small mistake in relation to the time. There was some mistake about time zones. I don't know how I misunderstood the time zone, but let's go with the session. And since there was this time zone problem, the template is not perfect, but let's go with the session. I believe you will love it. Why Synapse Analytics is beyond Azure SQL Data Warehouse? Some of you may have used SQL Data Warehouse before, and some of you may have heard about Synapse Analytics as a new tool provided on the Azure cloud. So why Synapse Analytics is beyond SQL Data Warehouse? Let's understand that. Uh, Simon made a great presentation video for me. Thank you very much for that. On the right side, you can see my contact. Feel free to get in touch. It will be a pleasure to connect uh, on this contact. Later, I put them again. So, why am I making this question on the title of the session? Why Synapse Analytics, what Synapse Analytics, and how Synapse works. So, why am I asking in relation to Synapse Analytics and SQL Data Warehouse? Because before we had SQL Data Warehouse, then Synapse Analytics appeared, was launched, and SQL Data Warehouse was not discontinued. Let's say discontinued, although it's not exact. Sorry, it was not exactly like this. So, what really happened between SQL Data Warehouse and Synapse Analytics? Why Synapse Analytics? Synapse Analytics is for big data warehouse, exactly as SQL Data Warehouse. And there was a problem before with the name of the SQL Data Warehouse because most people confused it. Most people think, oh, since there is a product called SQL Data Warehouse, I will use to build my data warehouse, and that is it. But this is not true, not exactly true. SQL Data Warehouse is used for data warehouse, it is, but it is used for huge data warehouse, very big data warehouse, because the SQL Data Warehouse is an MPP platform, massive parallel processing. SQL Data Warehouse is able to get our requests and break down our requests in many different nodes and then get the result, join the result, and give us the result. So it's not for something small, it's for a very big environment. So uh, many people mistaken the name, thinking data warehouse needs to be there. No, it doesn't. Data warehouse can be on any SQL database. It can be on Azure SQL, can be in a SQL virtual machine, not a problem. It only needs the SQL data warehouse when it becomes big. It becomes very big. Then we have data lakes. Uh, when the internet arrived, the concept of the data lake arrived as well. Why? Because the internet brought us huge amounts of data, and huge amounts of data that most times were unstructured. Logs of websites, for example, is a good example of unstructured data. that may be useful to analyze our customers' behavior. And then we started using data lakes. Data lake has this name because the huge amount of data that we put inside the data lake is not uh, is not possible to move this huge amount of data. Possible always is, but would you like to move huge amount of data to make some processing? No. So the data lake keeps the data there. We don't move the data. We store the data in the data lake and we don't move more the data. Then we make the applications point to the data lake. And if you want to make a data lake, we would use Spark and Databricks. Spark and Databricks to make a data lake. Uh, and to receive all this data, we are talking about big data warehouse, we're talking about data lake. How does data get into this environment? For the data to get into this environment, we'll use some ETL solution or ingestion solution. And for this, we have the data factory. Data factory is a solution for that. Then we have machine learning, the need of machine learning. We need to generate some intelligence for this data. And how can we do that? We can use Azure ML. Visualization, we need to visualize the data. We use Power BI to visualize the data. Data lake house. The idea of a data lake house is to be able to manage all this data. The big data warehouses that are a structured set of data and the data lake that is an unstructured set of data. So we have a data lake house. How can we implement a data lake house? Using Alt tab. What I mean about using Alt tab, I mean that you need to put all these tools together and keep moving from one to another. That's it. So you would need to put all these tools together to build a data lake house. And if I talk about a virtual data lake house, this is even more complex because this happens on big corporations. Uh, Big corporations sometimes let their branches manage the data, and each branch starts to make some kind of data intelligence storage, maybe a data warehouse, maybe a data lake, and so on. But at some time in the future, the main office of the corporation would like to get the data, get information about how the company is going, and how this would happen, how this would be done. The point is, since each branch already built, let's say, a data lake, this data would not be moved. So the main office should create a virtual data lake, should virtualize a data lake, mapping the data that is on the branches as if it were in the main office. But it's not, but it will appear as it were in the main office. What tool should we use? We should only dream with it because there was no tool to build this before. And this is how we were. This is a picture from the 80s, but we were exactly like this. Take a look on the amount of tools that we were using. We're using all these tools. So exactly like this guy, using all these tools. And suddenly we transform everything. We will go ahead and transform everything in a single tool. We'll put everything together with a single tool. That's it. So now we can make all these tasks using Azure Synapse Analytics. That's the idea. So Azure Synapse Analytics uh, achieves the purpose to make all these tasks. Manage big data warehouses, a data lake, the ETL, machine learning, visualization, data lake house, and virtual data lake house. So you ask, S- So all these tools that all of us are using now, like Power BI, like Data Factory, are they being replaced by Synapse Analytics? No, no. It's not a replacement. Synapse Analytics is making like a partnership with these tools. A partnership with these tools in some way that uh, you have a single point of access to all these tools. You go to a single place, you go to Synapse Analytics, and from Synapse Analytics, you access all these features that are provided by different tools. You have different tools to provide all these features, but now you have a single place to manage all of them. Very few tools were really incorporated in Synapse Analytics, and one of them is the SQL Datawarehouse. The old SQL Datawarehouse became one piece of the Azure Synapse Analytics. And this explains the question from the title of the session. Why Synapse Analytics is way beyond SQL Datawarehouse? When SQL Data Warehouse disappeared and Synapse Analytics was put as maybe many people would say a replacement, many people will get confused and think, oh, Synapse Analytics is SQL Data Warehouse and it's just a change of name. No, no. Azure Synapse Analytics is way more, as you are seeing on this slide, and the SQL Data Warehouse became a small piece of feature inside the Azure Synapse Analytics. So it's exactly like this picture where we replaced all the old gadgets from the 80s by a cell phone. A cell phone does all this. It's exactly the same. It was just in time to replace all those tools that and all those alt tab tasks that we need to keep jumping from tool to tool and so on by a single tool, Synapse Analytics. So, what's Synapse Analytics? How does it work? In a single sentence, Synapse Analytics is the Azure virtual and physical data lakehouse solution. Mind that I included both. We can use Synapse Analytics to make a physical data lakehouse, a virtual data lakehouse, or both together. We can build both together, no problem with that. And how Synapse Analytics works. So we have Synapse Analytics, and Synapse Analytics, when we provision Synapse Analytics in Azure, we'll be provisioning a Synapse Analytics workspace. Inside this Synapse Analytics workspace, we have the SQL On Demand, the SQL Pool, and Spark Pool. So we can work with Spark inside Synapse Analytics, manipulating data on our data lake. We can use SQL Pool. This SQL Pool, that's the SQL Data Warehouse. The old Azure SQL Data Warehouse became the SQL Pool inside the Synapse Analytics workspace. So that's it. SQL Pool is the SQL Data Warehouse. And then we have the SQL On Demand. SQL On Demand on Synapse Analytics is it's a mind-changing tool. Why? Because one thing that we were sure before Synapse Analytics is that if we had to use SQL Data Warehouse, we would pay lot amount of money. a huge amount of money. It's expensive. Well, SQL Data Warehouse was expensive. SQL Pool is not cheap. It's not cheap. But SQL on demand is different. SQL on demand basically is the ability for us to make SQL queries on demand without have something provisioned, without being charged by minute. We just execute the query when we would like, and we are charged by gigabyte that we transfer. Is something like as $5 by 10 gig, or even by 1 tera, $5 by 1 tera for 1 terabyte of data transfer, something like that. I may have be mistaken the value, but it's on this level of charge. So it's a very small amount that is charged, and this opens huge amount of possibilities because we can just provision a Synapse workspace and use SQL on demand to make SQL queries over our Azure Blob Storage. It's simple. Then we have Synapse Studio. Synapse Studio is the tool that managed to join everything together. The single tool. The other tools too. It's Synapse Studio. And this is basically the cell phone on the picture that I showed before. And inside Synapse Studio, besides the pools that are part of Synapse Analytics, we have data integration, the ETL part, how to ingest data inside Synapse Analytics. What is used for data integration? Data Factory. Synapse Analytics incorporated like a copy of Data Factory. So Data Factory works inside Synapse Analytics. It's Data Factory is like that. Power BI. Uh, of course, Synapse Analytics hasn't incorporated Power BI, but it made a very good partnership with Power BI. We can see Power BI Workspace inside Synapse Studio. We can see Power BI datasets inside Synapse Studio. We can turn our Synapse data on the SQL pools, on the Spark pool, into Power BI datasets and create new reports inside the Power BI workspace. So we have a very good integration with Power BI and Azure Machine Learning. Also using Synapse Studio, we can apply machine learning over our datasets in the Synapse workspace. So all these tools are integrated together using Synapse Analytics and using Synapse Studio as a tool to integrate everything. The main idea, the main challenge that made Microsoft to start this huge and absolutely great tool was the learning curve to manage all the data platform, data intelligence platform, data lake, data warehouse. So we had to use all these tools. How one person, one professional would learn all these tools at once. So Microsoft joined them, integrated them in a single place to make it easier and make the learning curve easier. So Azure SQL Data Warehouse became the SQL Pool. This is just a change of name. But now we understand how Synapse Analytics is way beyond that, because SQL Pool is just one element inside Synapse Analytics. Now let's go to some demonstrations. So I have here my Azure portal. Okay, and I have a Synapse workspace already provisioned. It's called Synapse Lake. So I have here the Synapse workspace provision. Let me open the Synapse workspace, Synapse Lake. And here we have the pools, SQL pools. I have the SQL pool called built-in. This is the SQL on demand. So I can create and make a query over my blob storage or any data source that I would like. It doesn't store data, but it queries the data. And we have the dedicated SQL pool, which is the SQL Datawarehouse. It's in pause. It's paused. So we have here two SQL pools, and I have also an Apache Spark pool. So my Spark pool, and I can also use the Spark pool with Synapse Analytics. So without these features, I can use Synapse Analytics from many sources. If I would like to use from other kind of sources, or the SQL clients or Spark clients or something else. So I have here the addresses. I have the address of the dedicated SQL pool, the serverless SQL pool, and so on. I have here separate addresses for every pool I have, but the way to use all of them together is to use Synapse Studio. So I can open and use Synapse Studio. It's opening. Here, here it is, the Synapse Studio. And the beginning is already great news for us. Take a look on how Synapse Studio managed to do exactly what I explained. New. I can create on Synapse Studio. From Synapse Studio, I can create a SQL script, a notebook, a data flow, Apache Spark job, Power BI report, or a pipeline, a data factory pipeline. I can create all of these from Synapse Studio. So I'm dealing with many different tools that before we would need to learn each one and work with each one individually. Now I have all of them working from the Synapse Studio environment. And to make things even better, way better, we have this learn option. The idea is to reduce the learning curve. So we have this learn option here in Synapse Studio. And let me browse the gallery. We use the option to browse gallery. So you will have a good idea of what I'm talking about. First idea is to ingest data. So if I will ingest data, I have pipelines. What we have here are pipeline templates for data factory, but not for the regular data factory that you know. They are the same. They are the same. But these will be created inside Synapse Analytics. These pipelines can be created inside Synapse Analytics. And I'm not saying that you can only create these templates. No, these templates are here to make your life easier. If you are in a scenario that fits with one of these templates, You only need to fill the gaps, fill the parameters, the missing data, and you will have the pipeline ready. But there is nothing preventing you from creating a pipeline from a blank environment. So we have the pipelines for the data factory. We have SQL scripts here. Many examples of SQL scripts. Some of them using the on-demand pool, some of them using the provisioned pool. Uh, Many examples of what you can do to process your data using both Synapse pools. And we have notebooks, Spark notebooks. Again, many templates to use Spark to process your data. That's absolutely great. But if these were not enough, we have the datasets. What are these datasets? These are public datasets offered by Microsoft, many of them offered by Microsoft, that can be used to uh, test the Synapse Analytics features. You can get information about COVID, you can get information about New York taxi, and many different data sets available for you to test the Synapse features. You can get this data set and start testing the environment. First, since usually we need to first ingest something, let's take a look of the data flows and pipeline. I have many things already developed here. Yes, we can develop something. We can develop scripts, notebooks, data flows, and even Power BI reports or data sets, and store them inside Synapse Analytics. Let's get the data flow. I have a data flow here where the import. This is importing data from a public storage Microsoft has containing weather information. See, who already worked with Data Factory is recognizing this going, it's Data Factory. Yes, it is Data Factory inside Synapse Analytics to make our life easier. But a data flow don't work by itself. It needs a pipeline. So we have pipelines as well. We have the data factory pipelines. So we can build data factory pipelines. We can build data factory data flows inside Synapse Analytics. That's great. Now let's get back to the beginning. I'll get to learn, browse gallery, and let's start with SQL script. I will analyze Azure Open Datasets using serverless SQL pool. Continuing. It's showing me the script, what the script requires, and let's open the script. It is connecting.
Maybe you would like to lab
Waiting.
next 5 to 10
Okay,
minutes if that's possible.
10 minutes.
Yeah.
Okay, great. Yeah, it's possible. So I'm connected to the built-in, which is the serverless environment. And I have database on the serverless environment, but what is interesting to note is that take a look on a database on this SQL on-demand environment inside Synapse. We don't have tables. We have external tables. We point to external places, but there is no tables. That's the point. The on-demand environment access data outside the environment, but don't store data. And here, let's take a look. I'm getting data from Azure Open Data Storage. I'm getting data from New York Taxi. And I'm using the open row set function in bulk to get this data. And the data is on Parquet format. It will read the data from all the files in the folders and bring it to me. So I execute. The selection sometimes fail. Select again, execute. There it is. It just made a query, a SQL query over a data storage managed by Microsoft, an Azure data storage managed by Microsoft. I have no idea where the data storage is. I only have the URL to the Azure data storage, Azure storage, and I'm reading the data. That's it. I don't need to be on a database, on a custom database to do that. The open row set works without one specific database. Then in this other example, I'm reading holiday data. The first one was reading trip data from New York taxi trips. Now I'm reading holiday data, holiday information, and weather information. I have all these here. Great. And let's make something more interesting. In this example, I'm filtering the data between the years 2009 and 2019, grouping by year to identify how many taxi rides happen on each year. And it's even more interesting the fact that I'm using a filter based on the path of the files, because the files are broken down in different folders for each year. And I'm extracting one variable, this star. I'm extracting variables from the path and testing these variables to get the data of the amount of taxi rides made by year. So I can have my data lake stored in an Azure Blob Storage, and I can read the Blob Storage using a server on-demand Synapse pool. And this charged me about $5 by terabyte transfer, something like that. It's very cheap. While it's executing, and since I'm short on time, let's open Learn again, browse gallery, notebooks. I'll open the first example of notebook, and here I have a Spark notebook. It's a very simple notebook, making some graphics, building some data. It's not reading from anywhere. It's building some data and making some graphics using Spark. And this notebook is using PySpark. I can run. This will take a while to run because my Spark pool is not active. So it will enable the Spark pool immediately and take some time to run. While it's running, it seems this thing is especially slow today. 1 minute and 45 to read this data. It's not something usual. Let me see if I have better example here. Oh, sorry, I opened the wrong script. Sorry, that's why the example was failing. But let's see if it. Now it's okay. Now it's already finished. So I can show something that can be done here. I have the number of taxi rides by year. And the point is, the interface also help us a lot. I can build a chart on the interface. I can change the type of the chart to a column chart. I prefer a column chart. And then define the category columns, current year, and legend as rides by year. So we can see here the taxi rides by year, and we see that about 2013 and 14 the rides started declining. Probably this is when the companies like Uber start operating, so the taxi rides start declining year after year. And just by making one query over our data lake, I'm able to analyze that, and that's great. And last but not least, we have Power BI here. I can integrate a workspace in Power BI. In my scenario, will not perfectly work because I have an account problem here, but we can see Power BI data sets, we can see Power BI report, but it will not open this report because an account problem that I have. But it's here, an integration with Power BI as well, and I can even transform some data set that I have to a Power BI data set and use to build the report. That's the idea. That's the idea, to have everything in a single place inside Synapse Studio. I hope this gave you all a better idea of how Synapse Analytics works, why Synapse Analytics is not only a change of name from SQL Datawarehouse, and how that we can achieve by using Synapse Analytics. On the screen you have my contacts. Feel free to connect, to get in touch. It will be a pleasure to connect. Thank you very much for attending this session.
Thank you so much, Dennis. That was a pretty crisp presentation and followed by a demo. I think Synapse analysis is something that one should go ahead and look into in the day-to-day basis. That should help in the production, and that's a really nice one. So thank you so much for your time. I love your background. I say you're sitting in the spaceship, and we're all in 10 minutes. We're already 10 minutes over of the time, so I'll just move to the next session. And thank you so much, Dennis, for all that you do for the community. We would love to have you back when in a couple of months or when you're available. Have a nice weekend, and thank you so much.
Thank you very much, Simon. Thank you very much for the invitation. Bye.
All right, so with that, we move to our next session, and that's by Dean. I cannot say his last name, I'm sorry. It's going to talk about SQL Server 2019 intelligent query processing, which sounds pretty interesting, as I don't see many people talking about giving session on this. And I quickly tell about the speaker. Dean is a senior DBA practicing SQL Server since version 7.0. And the reason I go ahead and read 7.0 is because if you go ahead and do a Google search, 7.0 was launched back in 1998, somewhere close to maybe I was born. So you see, there's a lot of experience coming in the next session. So let's go ahead and invite our next speaker, Dean. Hi, Dean. Welcome to the SQL Server Virtual Conference.
Hi, Simon, and thanks for the nice introduction.
Thank you so much for your time. And I know we have already taken almost like 13 minutes, right? So I'll just go ahead to ask you to go ahead and start sharing your screen so that we can go ahead and follow on time. Then after the session, we can do some chit chat.
Okay.
All right. So I have your screen.
You can see my screen?
Let me go and add it. It's loading. Perfect. SQL Server Intelligent Query Processing. I see your slides. Yep.
Okay, thanks.
Thank you.
So, hi to everyone. As Simon already said, I will talk about SQL Server Intelligent Query Processing on SQL Server 2019 and 2017. Intelligent Query Processing is just a marketing name for 7 features that are available on SQL 2019, and 3 of them were available already on SQL 2017 under a marketing name Adaptive Query Processing. So let's start. A little bit about me. I'm a senior database developer. I love to performance tune databases and SQL servers. I'm a Microsoft certified trainer, co-organizer of SQL Saturday Croatia and past meetup SQL Server User Group Croatia. And here's my contact details. You can find me on LinkedIn, Twitter under Dean Savovic. So if you have some questions about SQL Server or about this session or about anything related to SQL Server, please feel free to reach out. So agenda for today are features from Intelligent Query Processing stack. So we will go through all of them. We will talk about a little bit about theory about them and show a demo about each of them. And at the end, we will have some room, I hope, for questions and answers. So the features under the Intelligent Query Processing stack is, as I already said, part of them are already available from SQL 2017 and are called Adaptive Query Processing. Those are adaptive joins, interleaved execution, memory grant feedback, and so on. Some of them on this slide are marked with 2 letters E, meaning that they're only available on Enterprise Edition of SQL Server or Developer Edition, but you cannot use Developer Edition in production. So in production, you can use only Enterprise Edition. So adaptive joins, memory grant feedback, and batch mode on row store are only available in Enterprise Edition of SQL Server. All others are available in standard. So 3 of these features, as I already said, are Enterprise Edition only features. And the thing I want you to remember that 6 out of these 7 features can affect your existing code, positively or negatively. So you can have query regressions or you can have improvements in your queries because of these features when you migrate to SQL Server 2017 or 2019. An important thing to remember is also if you migrated your databases to SQL Server 2019 and adjusted the database compatibility level to 150, which is the compatibility level of SQL Server 2019, all features are activated by default. And on SQL 2019, OLTP workloads interact significantly with intelligent query processing features. On 2017, they interact by using column store indexes. So basically, I think that you would use column store indexes basically more on data warehouse solutions. So on 2017, the story is different. Let's talk about execution plans and how intelligent query processing affects execution plans of the queries. Very interesting topic. Queries that are affected by intelligent query processing are the queries that use table variables, tables that use user-defined functions, queries that use multi-statement table valued functions, complex queries, and queries that use tables with skewed data distribution. They all can benefit from intelligent query processing, but there can also be some regressions in the behavior of the queries. Issues that are resolved by intelligent query processing are inappropriate operator choice, meaning nested loops versus hash match join or vice versa, and memory grant under or overestimation. Big difference between SQL Server 2016 and prior and 2017 and 2019 are that on SQL 2016 and prior, all planned decisions are made at compile time. So not after the query is compiled, nothing can be changed in the execution plan, in the execution of the query. And once the plan is created, only recompile or memory pressure if the plan is forced out of the plan cache. So nothing other than this can change the execution plan that is in the execution plan cache. On SQL Server 2017, we have three improvements. Multi-statement table valued functions interleaved execution, which means that SQL Server will execute the multi-statement table value function in compile time and get the exact number of rows that function will return in the query, and have the exact cardinality of that function. This is a big change comparing to 2016 and prior SQL servers, because prior to that, SQL Server has a hard-coded guess of 1 up until SQL 2014 and 100 after SQL 2014. Next, we have adaptive join and memory grant feedback that runs in batch mode. Adaptive join also runs only in batch mode. And these are the ways that SQL Server can, after compiling the execution plan, change the execution plan that is in the cache. So this is really a big thing. And on SQL Server 2019, there are additional adaptive improvements like interleaved execution of table variables, which behave the same as multi-statement table value functions. So SQL executes them and gets the correct cardinality. And memory grant feedback in SQL 2019 now works in row mode also. So in 2017, it worked only in batch mode, so using column store indexes. And we have TSQL inlining, which is a great feature also. So now it's time to go through each of those features in detail. So first of them is adaptive joins, which works in 2017 and 2019, but only in batch mode. So meaning that we need to have a column store index on the table that is touched by the query. And adaptive join is a new operator you will see in the Management Studio, which can in runtime decide whether it will execute as hash or nested loop join. So adaptive join operator is a logical operator, it's not a physical operator. In runtime, SQL Server decides based on the threshold that is calculated at compile time of the building the execution plan, whether the hash or nested loop join will be used. As I said before, this feature is on by default. You can turn it off by altering the scope configuration of the database and setting batch mode adaptive joins to off, or by using query hints. This is a good feature that handles oscillations in number of rows that are coming into the adaptive join, meaning that SQL Server at runtime can, if the number of rows is less than threshold, choose to use nested loop join, and if the number of rows coming in this number one table is greater than the threshold, SQL Server Query Optimizer will use hash join. So this is how SQL Server handles oscillations with adaptive join operator, and this applies only to select queries. There is obviously some overhead because SQL Server at runtime has to decide whether to use nested loop or hash join, but this overhead is compensated with SQL Server choosing the right operator to do the job. Let's now switch to Management Studio and show this in practice. I will zoom in so you can see what I'm talking about in this demo. We will use wide world importance DW database, make sure it's in compatibility level of SQL Server 2019, and we will free proc cache. Okay. Let's go into this database. With this statement, I'm just making sure that column store index exists on a fact order table, because I need it for adaptive join to kick in. Okay. And now let's execute these two queries. These two queries are exactly the same. The only difference is that the predicate for the quantity is 360 in the first query and 361 in the second query. So let's run them together. Let's include actual execution plan. Okay, it's already included. And run this. First query returns 206 rows, and the second query returns 0 rows. Let's see the execution plans. You can see here adaptive join operator, and here also adaptive join operator. So the first query, let me show you when I hover over the adaptive join. You can see here that adaptive threshold I talked about is 67.89. So if the first table running into the adaptive join has more rows than 67.89 in runtime, remember that, then the operator will transform to hash match, as it is here. And in the second query, we can see that adaptive threshold is 6.5. Why it is different than in the first query? Because it's a different query because of the different predicate, and my database is in a simple mode of parameterization. It's not enforced. So now SQL Server, because 0 rows are coming into the adaptive join operator, is choosing nested loops. So in runtime, SQL Server chooses nested loops or hash join. If you, for some reason, identify that after migrating to SQL Server 2017 or 2019, if you experience some regressions in your queries, you can easily disable the batch mode adaptive joins by using this hint at query level, or you can disable it on the database level. But I highly recommend that if you determine that some query is slower than before because of this batch mode adaptive joins, you can use this hint to disable the adaptive joins, and now you get the old way of compiling and running the execution plan by SQL Server, and you will not see adaptive join operator, but SQL Server Query Optimizer will choose nested loop or hash join at compile time and use it at runtime. Okay. Next feature is memory grant feedback. It works on 2017 in batch mode only, and in 2019 in row and batch mode. What is memory grant feedback? Well, this is a feature where SQL Server at runtime can modify the memory granted to the query. So if SQL Server determines that too much memory was granted to the query, in the second execution of the same query, SQL Server will decrease the amount of granted memory, and vice versa. If the granted memory was too little, and because of that you had some problems with the query, like spill to MDB or something else, SQL Server at the next execution of the same query, which is fetched from the execution plan, will give this query more memory than it was initially given. So this is again modification of the execution plan in cache. You can also disable it or enable it, and if SQL Server encounters a situation where memory increase, memory decrease fluctuation is going in the loop, you can imagine that this can happen. After about 30 occurrences of this increase and decrease fluctuation, SQL Server will disable memory grant feedback for this statement. Let's see this in the demo. Okay, let's include actual execution plan. The first part is the same in all the scripts. Make sure that it's in 2019 ability level. And now we will execute this query and take a look at the properties. So let's run this. Okay, it's taking more time than... Okay. So in the execution plan, we see the exclamation mark with the select operator. Let's click on it, hover it, and you can see that the query had to wait 13 seconds for memory grant during execution. Okay, this is why we waited for the query to execute. But the more important thing that I'm talking about here is the query memory grant detected excessive grant, which may impact the reliability. Grant size initial 23 megabytes, final the same, and used only 120 kilobytes. So this is something that memory grant feedback should correct. Let's take a look at the properties window of the select operator, and under memory grant info you can see here that is memory grant feedback adjusted. No, this is the first execution, so there is nothing to adjust because the query is not yet in the execution plan cache. Let's run this query again. Okay, again we have an exclamation mark. Let's see what it says now. It says the same message. Let's take a look at the memory grant info. It's still saying the first execution. There is something wrong with my plan cache. Let's run it again. Okay, now we don't have exclamation mark on the select statement, and memory grant info says, is memory grant feedback adjusted? Yes, adjusting. Now if I execute it a few more times, this message would change to yes, stable. Okay. Let's go to the next feature, and next feature is interleaved execution. Interleaved execution is a feature that applies to multi-statement table valued functions, which had a fixed cardinality of 100 from SQL Server 2014, and before that the fixed cardinality was 1. And this could lead to numerous problems when you had multi-statement table valued functions that returns hundreds of thousands or millions of rows. SQL Server 2017 and 2019, when encounters a multi-statement table valued function, pauses the optimization at compile time, executes the function, captures the accurate cardinality, and then resumes the optimization. And at runtime, because the function was executed at compile time, it doesn't have to execute it again. So he only executes it once, and this is during the compilation of the execution plan. This only applies to select queries, and as always you can turn it on and off. Let's see this in a demo. So this is the demo. Let's clear the cache. Okay, this is our function. It's a very simple function that takes start and end dates as parameters and returns a table, and we insert some rows in that table from the fact order table, where order date key is between start and end. So very simple but multi-statement table value function. Okay, so this is not an inline function. And now let's take a look how this behaves under compatibility level 150. So this is SQL 2019. I forgot to include the actual execution plan. Sorry about that. And in the execution plan, we have an estimate the number of rows of 5,281 and actual number of rows is exactly the same. This is what we expected because of what I told you about this feature. And we can disable this with a hint or by setting the compatibility level of the database to compatibility prior to 2017 SQL Server. I'm putting this database into compatibility level of SQL 2016. And now if I run this, we get an estimate of 100, and actual is the same, of course, because it is the same function and we are using the same set of parameters, as you can see here. Okay, when could you have problems with these features? Well, you could have problems when you rely on the old cardinality estimator. So if you rely that for your multi-stable table value function, you will get 100, even the function is returning more rows than that, then you could have regressions in after migration to SQL 2017 or 2019. Those three features were the features of the SQL that were available already on SQL 2017. Now we will go through the features that are available on 2019 only. So the first one is table variable deferred compilation. The story is the same as with TVFs. The SQL Server pauses the optimization of the execution plan, executes the table variable, and gets the actual row count. Before that, it was a one row guess. So on SQL 2017 and prior. This doesn't mean that table variables get column statistics, and this doesn't increase recompilation frequency. And what happens with the variations in table variable cardinality? Well, this is the same as with any other predicate. You are prone to parameter sniffing, which could sometimes be a problem and sometimes not. Let's see this in a demo. Okay. Let's include actual execution plan. We have a table variable named foo, and order key is the only field in that table. We are filling in the table variable with rows from the fact order table with the same parameters we use for the multi-statement table value function. And then we are selecting from fact order and joining this foo table variable by order key. Let's see how this behaves on SQL 2019. So we get the execution plan, and in the execution plan you can see that estimate is spot on, 5281, and actual is 5281. Sorry, this one. So this is because SQL executed the table variable and got the exact number of rows from that table variable. If we lower the compatibility level to SQL Server 2017, we will get different results. So now I'm executing the same set of statements I executed before on SQL 2019. The only difference is the compatibility level, which is now 140. So SQL 2017. And let's take a look at the estimates now. It's fixed guess of 1. And the actual number is, of course, 5281. Next feature, a really good one, is Color UDF inlining, available on SQL 2019. So what is Color UDF inlining? So it applies obviously to Scholar user-defined functions. And the SQL Server Query Optimizer is now able to transform these user-defined functions into relational expressions. This is set-oriented, and it is able to run in parallel, which was not the case in the SQL 2017 and prior. Whenever you had the UDF in the query, this query couldn't run in parallel. It was only able to run in serial mode. And in Management Studio, when you took a look at this query, it lacked of costing. This was a black box to SQL Server and to us when looking to the execution plan in Management Studio. And let's see this in action. Let's see a demo. Okay, let's do the same thing as we always do. Okay, and now we have a scalar function named total price, which takes a customer key as input parameter, and from fact order for this customer calculates the total including tax. It calculates the sum of that, puts that in the variable total price, and returns total price. So let's create this function. Okay, and now let's run the first query, which is on SQL Server 2019. And let's set statistics time to on. So this query runs relatively fast. It executed in 2 seconds. And the execution plan, we can see that SQL Server unwrapped that scalar function. It is here. It's getting data from the order table. Aggregation we can see here, and so on. And when we disable TSQL Scholar UDF inlining, so we are still on SQL 2019, but we have disabled UDF inlining. Let's run this query. And this query just, it will not execute even in the satisfactory number of seconds. I will not wait for the query to execute because it will run very, very slow. Let's take a look at the estimated execution plan. And you can see here that UDF is in the different part of the execution plan. You don't even have it in the, it's a black box to SQL Server. If we display the estimated execution plan of both queries, you will see that the query that doesn't allow SQL UDF inlining is cheaper by Management Studio, but this is only the estimate, of course, and this one is more expensive, which is a total lie. Let's go to the next feature. Next feature is batch mode on row store. So this works only on SQL 2019 and on Enterprise Edition of SQL Server. It enables you to run batch mode queries without column store indexes. So what does even batch mode means? SQL Server can execute queries in row mode or batch mode. Row mode is the old way, available from forever, and it means that the first operator, for example select, asks for one row from the next operator, and this operator asks the next operator for one row, and it goes to the index seek or index scan or table scan operator, which then retrieves one row and gives it back to the operator that asked for that row. In batch mode, the procedure is similar, but operator is not asking for one row, but for batch of rows. How many rows will be in the one batch depends on the size of the row. So what are the scenarios which can benefit from this? These are analytical queries on OLTP databases, joins and aggregates, scenarios in queries which are CPU bound, and if you cannot afford to create a column store index on your OLTP database because it is too much overhead for you and for your database. Operators that can be run in batch mode are hash join, hash aggregate, sorts, window aggregates, filters, concatenations, and compute scalar. And there are some limitations, like only disk-based tables and indexes can be used. You cannot use in-memory tables and expect to be run in batch mode, and you cannot use LOBs, sparse, column sets, and XML. So let's see this in a demo. Let's put the database into compatibility level SQL Server 2019. Let's go into wide world importance DW. Let's drop the column store index on the fact order table to show that batch mode works without column store indexes on 2019. And we are running the same query. These two are completely the same. The first one has a hint allow batch mode, which is not needed, but let's have it here. And this allow batch mode disallows the batch mode from the second query. Let's execute this with actual execution plan. And let's take a look. So first query returns 100 rows and second returns 100 rows also because they are the same. First query that used batch mode ran in 163 milliseconds and the second one in 348. So the first one was quicker. And if you take a look at the operators, you can see that estimated execution plan and actual execution plan mode is batch. And on the second query, it is row. The difference in the execution time between these two queries is not significant, but when you're talking about hundreds of thousands or millions of rows that have to be processed by the query, then the difference will be much higher. And then we have approximate query processing feature, which introduces the in SQL Server 2019 approx count distinct function that allows you to return to the client approximate number of rows, distinct rows, and it guarantees up to a 2% error rate within a 97% probability. The most important difference between count distinct and approx count distinct is that approx count distinct will use much less memory to do the same job, and it will run faster, of course, but you will not get the exact number of rows. So let's see this in a demo. Okay, let's use AdventureWorks wide world importance DW. And we are counting order keys on fact order. Okay, you see that the result is different. This is an approximative result. This is the exact number of rows, and I didn't include actual execution plan. Sorry for that. I will do this again. And in the execution plan, you can see that select statement had a memory grant of almost 0, and almost 0, and this one had 23 megabytes. This one. So it's much higher memory usage when you use count distinct in contrast to using approx count distinct. Okay, this is all I wanted to say. Do we have any questions maybe?
Yeah, Dean, thank you so much for that session. We'll take a couple of questions and then we'll move to the next session. The first question comes from your choice. He says, does IQP solve parameter sensitivity related problems?
Parameter sensitivity related problems, like parameter sniffing? The answer is no.
Okay.
Because it partially solves it with adaptive joins. When you have a different number of rows coming into the input table, into the adaptive join, because it will change from nested loop to hash join when the number of rows is significantly higher.
Mm-hmm.
But in the feature that uses table variable interleaved execution, you can have big problems when the query is executed for the first time with the table variable with 2 rows, and then you put 100,000 rows in that table variable. It will use the same execution plan as it did on the first execution. So no, it doesn't solve the parameter sniffing problem.
Okay, that definitely makes sense. We'll take one more question from Bhaskar as we're running out of time. He says, how to deal with performance regressions while adding new QP features?
How to deal with them? The best way, and I recommend this to all, is to use query store.
Okay.
So the way to upgrade your database to SQL 2017 or 2019 is to use the query store.
Mm-hmm.
First, run the query store with the old compatibility level for, I don't know, a few days or 1 week, whichever is you need to capture with query store your normal workload. So
Okay.
run it for a few days or a few weeks. Then switch the compatibility level to 2019. And then in Query Store, it is very easy from the Management Studio to get the regressed queries. And then for those regressed queries, if there are not so much of them, so many of them, just apply the hints to use the old compatibility level. I showed you those hints. Or if there are many of those queries, you can just degrade the compatibility level of the database, but then you don't have the intelligent query processing on your database. So I would recommend to use hints on queries that have regressed.
All right, so I think we still have a couple of more questions coming for a few people. Maybe you can come back in the comments and you can drop in from YouTube as we're running out of time, Dean. But thank you so much for your time, Dean. It was an amazing session. A lot of presentations and demo coming in just 45 minutes. And thank you so much. And hope to see you soon. And have a nice weekend.
Thank you. Same to you.
Bye. Take care.
Bye.
All right. So having said that, we now move to our next session. That's by Gianluca. I just hope I say that name correctly. I think he's a fan of racing cars, and that's why he's going to talk about benchmarking in the cloud. So without any further ado, I'll just bring the guest in the stream. Hi, Gianluca.
Hello.
What an amazing background.
Hello, thank you.
Thank you so much for joining, Gianluca, and contributing to this conference and this community. We really look forward to your session, and I won't take much of your time, and you can just go ahead and start to share your screen, and they'll add it to the stream.
Excellent. So I'm gonna go and share
And
my.
while you do that, I do recall that you were one of the speakers in the Light Up conference too, and you just said "light up." I remember that. Oh, that was a great conference. I loved it.
Can you see my screen?
Yeah, I can see
sharing?
your screen, and now I'm gonna add it to the stream. Everyone can see your screen now, and next 45 minutes is all yours.
Excellent, thank you. So let's go. So what we have today is benchmarking in the cloud. A few words about me. My name is Gianluca Sartori. I'm an independent SQL Server consultant, a data platform MVP, and I've been working with SQL Server for a very long time because I'm old. And currently I'm working as a DBA at a famous Formula One team in Italy. And if you want to read my blog, you can find it at spaghettidba.com. And if you want to follow me on Twitter, my handle is at spaghettidba. So the agenda for this session, first of all, we're going to have a look at benchmarking. So why we take benchmarks and what we want to do with those. And then we will see what are the tools and the challenges involved. And we will see that it's not easy to work with benchmarks. And then we will move to the cloud, where things are even more complicated. We have less tools, more challenges, and we'll see how hopefully workload tools will solve all of those. So let's go. First of all, definitions. What's a benchmark? Well, it's something that describes the performance of your system in a given scenario. So if I went to my server and I took a picture of what performance looks like, that is a benchmark. And it's good to know what's the shape of the workload in my environment, because it helps me to evaluate other scenarios, different scenarios that I may want to move to. Example, I may want to upgrade my hardware or virtualize my physical SQL servers. And I would like to know whether that is a good or bad idea in terms of performance. Or maybe I want to upgrade my software stack. And that means any part of the stack. So SQL Server, yes, for sure, but also Windows or the application service or anything that is in the software stack. And also helps me when I want to compare my current performance with what I would have in a virtualized environment, or if I migrate to a different environment, like moving to the cloud. Another thing that is interesting that we can do with benchmarks is rating how good my tuning efforts are. So I may want to try and change some knobs at the server level to change some configuration values. Or maybe I want to do something inside the database, like adding indexes or rewriting some store procedure or view, and see whether that is good or bad for performance compared to what I have now. So what do we have in a benchmark? Well, as we said, we have performance data, so something that describes the performance of the system overall. And we will probably have things like the number of batches per second, or how much CPU is being consumed, or other interesting performance-related data like the weight stats. But another very important part of the benchmark is the source workload. So the queries that are running in the system and determine the performance numbers that we are seeing. So along with the queries, we may want to capture some performance information related to those specific queries, like the duration or the CPU consumed or the reads and writes and so on. So how does it look like as an overall process? What we probably want to do is have our production environment, and we run a capture tool against the performance, the production environment, and we get a benchmark. And as we said, it contains some performance data, and then it contains the workload, all the queries with the performance information related to the queries. Once we have this is the baseline, what we want to compare against a different environment. So in order to do that, we need to have the target environment, the test environment in this case, and we need a replay tool that is capable of going through all the queries and the workload and replay them against this environment that we want to assess. And while the replay is running, we also need a second instance of the capture tool that this time will capture how performance is looking like on the test environment. And again, what we get is another benchmark with the workload data. And what we do at this stage is compare the two. And usually what we want to spot at this stage is things like regressions. Imagine that you are moving from an older version of SQL Server and you want to move to a newer one. You may run into some regressions, and you better catch those before you upgrade to the new version of SQL Server. Or maybe always talking about upgrade scenarios, we may want to catch those unwanted scenarios, like features that stop working altogether, or other things that we want to catch is how good the tuning efforts are. So the new environment may be an environment where we already have applied some of our tuning measures. Good. So if you ever tried this, you probably know that this is a bit hard. It's not an impossible task, but it is a bit hard. And we need to know how to capture the source workload and its performance data. And there are many tools to do that. We need to understand what we need to capture, and it's not always straightforward. And we also need to understand which replay tool we want to use. And that depends on how we capture the data in the first place. And then we will have to compare the results. And again, there are tools for doing this. So the main choice here is which tool to use. So let's go straight and describe what are the tools that we have in SQL Server to capture workload. Well, the first that comes to everyone's mind is Profiler. It's been around since forever, and it's pretty easy to use. You just need to fire it and click on one of the templates and say go. And then Profiler starts capturing all the activity on the server. The downside to using Profiler is that it has a non-negligible performance impact on the server. So I wouldn't suggest pointing Profiler to a very busy server because it would end up slowing it down. So extended events are really good for capturing performance and events from a server without slowing it down too much. Microsoft designed this feature to have a low performance overhead on the server being observed. There's a couple of downsides to using extended events. It creates very big files, and also it is not compatible with all the versions of SQL Server. If you're working with a version prior to SQL Server 2012, you don't have extended events there. And we have some events in 2008, but it's not something that you could use to capture a whole benchmark. So what you end up doing in all the versions is using SQL Trace, which is old school and deprecated, but it still works. And also it is compatible with a lot of analysis and replay tools. We may also want to capture performance from the Windows point of view. So this is, in the end, capturing performance counters. And we need to know which ones to capture. We have some counters related to Windows in general, and some specific counters for SQL Server. There's a tool, an open source tool that you can find on GitHub, which is called PAL. And this helps you understand which counters are meaningful for many Microsoft applications, including SQL Server. So all you have to do is download it and go to the installation folder, and it contains templates with all the list of the meaningful counters to capture. And once we have the data, we need to analyze it. And we have tools for that. The ones that have been around the longer are RML utilities. And this is a set of command line utilities. And it contains a tool which is called read trace. And as the name suggests, it reads a trace and writes the data to an analysis database. And then you can visualize that data using a tool called Reporter, which is based on the data that you have in the database. We have other tools like SQL Nexus, other ones like ClearTrace. ClearTrace is really interesting because it analyzes the trace files, and it can also do the normalization of the queries. So this means that if you have some constants in your queries and you have many instances of the same ad hoc queries, without normalizing the query, so removing the constants and replacing them with placeholders, you would have the performance information broken down by the individual instances of the statement. And normalizing them gives you the ability to see all the instances of the same query together. Well, what else do we have here? Of course, we have PAL that helps you analyzing the performance counters. And there's an interesting tool that's been released some years ago by Microsoft, which is called DEA, the Database Experimentation Assistant. And it's an A/B testing tool that helps you capturing a baseline and a benchmark and compare the two using distributed replay and some R charts. For replaying your workload, of course, we have Profiler, but that's more useful for debugging or troubleshooting rather than for replaying a whole workload. It's good because you can set breakpoints, you can pause the replay, but it's not really suitable for big workloads. RML Utilities contains a tool for replaying a workload, and it's called OSTRESS. And it can work on the output of read trace, and it has two ways of replaying the workload. The first one is stress mode, and it runs all the query one after the other without waiting for any pauses between the queries. And in replay mode, it tries to mimic the source workload, and it tries to respect the poses between the statements. So if you have a user that goes to a website and does some clicks on the user interface to make some things happen on the back end, and queries go to the database, the pause between the statements has to do with how long it takes to the user to click around on the GUI. And in order to mimic that on the database, you can use the replay mode. Distributed replay has been introduced in SQL Server 2012, and it can do basically what OSTRESS does, but it has one additional feature, which is the ability to run in parallel using multiple nodes to perform the replay. Good. So using all these tools, which I call the traditional benchmarking tools, the overall process looks like this. You have your production database, as we said, and what you do is you capture the workload to a set of files. And then what you do is you process these files, writing to the analysis database, and you create a set of other files that you will use later to perform the replay. So the replay tool accepts as an input the stub files, which contains all the queries to replay, and runs them against the test database. While this replay is running, again, you need to run a second capture. So you produce a second set of trace or XCL files, and then again, you have to process them to dump the information to the analysis database. And in the end, what you do is you run your reports on top of the analysis database to compare the before situation to the after situation. Well, that's a bit complicated. Many things can go wrong in this process. So imagine you could fill the disk. When you have a very busy source instance and you are not filtering enough your activity, you produce these trace files or XCL files very, very quickly, and you can end up filling the disk on the server. And another thing that often goes wrong is when you process these files, so these are gigs and gigs of files, the utility that has to process these files sometimes crashes without giving you any clue about what is wrong in the files. And that's really frustrating if you've been capturing your workload for hours or even days. And the same could happen when you are testing. So even when you do that on the second phase, on the benchmark phase. So if you move to the cloud, things get even more complicated because of all the tools that we have shown, some will work and some will not. First of all, we need to understand which kind of cloud we are thinking of. So if it's infrastructure as a service, it's a VM somewhere. So it doesn't really change from what you get on premises. The same tools will work even in the cloud because it's a VM, so everything works. You have control over everything. But if you move to platform as a service, some things are not under your control. Mainly, you cannot write to the local disk, which is required by traces. So in order to capture a workload, you don't have the ability to use traces. All you can do is use extended events, and you have two possibilities. You either write to a blob storage file target, or you can use the streaming API for extended events in order to receive the events directly to a client listening for those events. And obviously, you cannot use Performance Monitor to capture BLG trace of the performance counters because you don't have access to the Windows machine. If we move to an Azure SQL database, things are even more restrictive here because obviously we still have the restriction on not being able to run traces. We can use extended events, but this time the only thing we can do is write to a blob storage file target because we don't have on an Azure SQL database the ability to stream extended events, because the feature relies on system table value function that is not available on an Azure SQL database. It is available only to sysadmins on a managed instance. So what can we do? We can switch to using workload tools. Workload tools is an open source collection of utilities that you can find on my GitHub. And you can use it to take care of all the aspects of benchmarking. You can use it to capture a workload, to analyze what's inside the workload itself, and you can use it to replay a workload against a target SQL Server. It has two unique features that you will not find in any other benchmarking tool. It works against Azure SQL database and managed instance. And the other interesting feature is that you can do real-time capture and replay. So you don't have to capture the workload first to files, but you can replay it in real time while you are capturing. Good. So what are the features in workload tools? Well, basically everything works around two main concepts: the listener and the consumer. The listener is what captures the events. So depending on what we are working on, so an older version of SQL Server or a newer version, a cloud version of SQL Server, we might want to use SQL trace or extended events, or we could also start a listener on a saved workload that comes from a previous capture taken with workload tools itself. And once we have a listener that produces all the execution events, we can feed these events to multiple consumers. And they could be of the type file consumer. So this saves the workload to a file. So we can use it later to replay or analyze the workload itself. Or we have an analysis consumer that is capable of taking these events and normalizing the queries and saving the results to the analysis database in real time. And then we have the replay consumer that is capable of executing the queries captured against a target SQL Server database. It's super easy to work with workload tools. All you have to do is feed a configuration file written in JSON to the main tool in the tool set, which is called SQL workload. And then it will execute exactly what is configured in the file itself. We're going to see it in a minute. And once you have all your data captured and your benchmarks, you can visualize the comparison of the before and after workloads using two possible tools. One is the included workload viewer, which is a GUI application included in workload tools, or you have a Power BI dashboard that is capable of showing what's inside the two benchmarks. Good. So enough talking. I think it's time to show you how this works. So I'm going to show you, first of all, how to analyze a workload using workload tools. So what this will look like, first of all, we have a production database. We may want to use SQL workload to capture the workload from the production database. And this will happen using the streaming API for extended events. It could be the streaming API in case we're using extended events, or a sort of streaming using SQL trace, but it has a streaming functionality on top. Once we have all the events in SQL workload, what it will do is we'll use the analyzer consumer, so the analysis consumer, to write this data to an analysis database once the queries are normalized. So as we said, it will strip away all the constants and group together all the queries that look the same except for the values in the constants. Okay, so let's see how this works. We're going to use a virtual machine for this, and we have 3 SQL Server instances. So one is SQL 2016, and then we have SQL 2019, and then we have an Azure SQL database. I'm going to use this DS3 database as the source for my workload. DS3 is a benchmarking database that you can get from Dell. It has been actually open sourced. So it's a synthetic workload that simulates a website that sells DVDs online. So it shows its age. It would be something about Netflix today, but again, it works. So what will we do? First of all, we said we want to analyze the workload. And how do we do that? Let's have a look at this from code. So first of all, we are going to run this analyze.cmd, and it will run SQL workload.exe. So this is the main executable for capturing a workload and analyzing it with workload tools. And as we said, we need to specify a JSON file that contains all the configuration. So let's have a look at this configuration file. It's pretty easy, and it contains basically this controller node, and inside we have a listener and the list of the consumers. So we will always have one listener and one or more consumers. The listener in this case is of the type extended events workload listener. So this means that it uses extended events in the background. And we need to specify how to connect to the server, so the name of the server and the name of the database, and we can specify some filters that will be pushed down to the extended events session. We don't have to create an extended events session because workload tools takes care of creating one exactly using the information that we provided in the JSON file. Good, so we're all set with the listener. The next thing we need is one or more consumers. And in this case, we're going to use an analysis consumer. It needs to know where to write the analysis information. So the name of the server, and then the name of the database, and the name for a schema. And we need to specify how often it needs to upload the information. This will create intervals of this size. So we're going to have some intervals every 60 seconds or 120 seconds or more. It needs to be a multiple of 60. And this will aggregate the data inside these intervals. Good, so if we run this, it is going to capture the workload. Well, first of all, we need to start the workload. As we said, this is a synthetic workload, so it needs to start buying DVDs using our DS3 database. And then, oh boy, the virtual machine is not responding. Okay, so network glitch. Good. So let's continue. Now we need to run this analyze.cmd that runs SQL workload. So now it says, let's have a look. It says, well, I'm using this file, this JSON file, and it has created a listener of the type extended events workload listener, and it is waiting for events. So if we keep this running for a meaningful amount of time, it will capture all the queries being run by the synthetic workload, and every 60 seconds or whatever we have specified in this JSON file, it will create intervals, aggregate all the data it has captured, and dump this information to the database. What it will do, as we have specified here, it will write to this SQL workload 01 database. So let's have a look. And you see that in the SQL Workload 01 database, we have some tables in the schema that we have specified in the JSON file. And it contains information about all the normalized queries and the details of the workload and some lookup tables for application databases and hosts, logins, and so on. It also contains some tables for performance counters and wait stats that are also captured during the execution of SQL Workload. Good. As you can see, 1 minute has passed, and now it has dumped this information to the database. What does it mean? It has captured 4,200 queries, and once the queries were normalized and grouped, 22 distinct queries remained, so those were written to the database. And if we keep this running for a while, what we will get is a database with information about the workload. We obviously don't have the time to wait for this to produce some meaningful data, but I can show you what happens if we leave it running for a while. We can run this workload viewer application, and we need to specify what's the baseline server, so the first one, and the name of the database and the name of the schema that contains the data. If we run this, what we will get is this. We have information for the CPU duration and number of batches per second in all the intervals. We have 1 interval per minute in this case, and this will help you visualize how the workload looks like over time. You can also have the ability to filter this by application, database, host name, or login name. And another interesting thing that you get is the ability to zoom in a particular part of the workload if you see something interesting like a peak or something like that. And you also have a second tab that contains all the queries and the workload. So this helps you rank all your queries by CPU or by duration or by reads, writes, and so on, or by execution count. And if you click on one of the single queries, you can get even details that show you how that particular query performed over time. And you can have the information broken down by application, database, host, or login. Good, so this helps you understand what's the shape of your workload. But what if we need to do something different? Oh, well, I closed code as well, but we're going to open that as well. Good, so if we need to save a workload to replay it later, what we have to do is, again, point SQL workload to the production database. What it will have is, again, all the events coming to SQL workload. And this time, instead of saving the information to the analysis database, we could save to a file and use that file later to open it and stream all the events contained in this file, again, to SQL workload. It will be a different instance of SQL workload, and we can analyze to the analysis database. And let's see how that looks like. Oh, I don't need the release notes. Okay, so we can go to the second example, and in this case, we're going to have to run this capture.cmd. It runs SQL workload, and again, we have capture JSON as an argument to SQL workload. So let's have a look. So capture.json, again, we have a listener, and it's an extended events workload listener. And this time we have 2 consumers. So the first one writes, as we did before, to the analysis database. But we have a second consumer that is of the type workload file writer consumer. And all we have to specify is the path to the output file. And as you can see, this is a SQLite file. So the workload goes to a SQLite file that you can use later to open it and use it as a source for a replay or for an analysis. So let's try to do that. We can go to this capture, and I'm going to use it. And as you can see, it says, okay, this is running, and it's reading the events from the stream. And it says writing event data to this SQLite file. So let's see what it is. We have this SQL workload.SQLite. SQL workload.SQLite. It is receiving data. It says also I'm writing 1,000, 2,000 events to this. And well, I can stop it. If I open this with a SQLite browser, I can see the data inside my events table, which is the ones that contains all the events and the workload. And this can be used as a source for a replay. We have all the SQL text here. All we have to do is take this text and execute it against the target SQL server. Good. So this is what we will do in the next example. So we are going to replay a workload by using a SQLite file as a source. So again, we have this production database. We could stream the events to SQL workload, and otherwise we can use a file, as I just said, as a source for SQL workload. It will receive all the events, and then we can analyze to the analysis database, but we can also stream these events replay these events, against the test database. And while this replay is running, we can analyze using a second instance of SQL workload that writes to the same analysis database, but to a different schema. So now we just need to run the reports on top, and we can compare the before situation to the after situation. Let's have a look. So let's go back to here, and we have the replay. So this time, what are we doing? Well, this startall.cmd runs replay and analyze. So replay contains SQL workload and replay.json. So let's have a look. Replay.json contains a listener that takes the events from a file. So it's a file workload listener. So the SQLite file that we captured in the previous demo. And with synchronization mode, we specify that we want to respect the poses and the source workload. So it doesn't run all the queries one after the other, but it waits for all the poses between the queries. And then we have the consumers. So the first one is a replay consumer. And this targets an Azure SQL database. And then we have an analysis consumer that takes the events from the source, so the baseline, and writes them to the analysis database. And while this is running, we also are running the analyze.cmd that takes this analyze.json. So let's have a look. And this time we have this pointed to the target of the replay. So while the replay is running against the Azure SQL database, what we do is we capture the execution events using blob storage to park the XCL files. This has to be configured up front. And then it will read these files incrementally and use it as the source of the events. And these events will go to an analysis consumer that will write how this workload is performing against the target database. And we can also decide to do more. We can use multiple consumers. In this case, I could write the events to another SQLite file because I feel like it. Good, so let's try to do that. And if I do it, what I get is two instances of SQL workload running at the same time. So the one on the left is running the replay, and the one on the right is connected to the Azure SQL database, and it is listening for the events coming from the Azure SQL database. Well, obviously, this needs to run for a meaningful amount of time before we get some information that we can compare in the workload viewer. We would need to wait at least for 10 minutes of execution, which we don't have for this demo. So I will have to ask you to trust this is actually working. So I can stop this. And I can show you what this looks like when you keep it running for a while. This time, instead of having one series of data, you get two series of data, and you can compare how the two stack together. So the green one is the baseline, the black one is the benchmark, and you can compare the two in terms of CPU duration and batches. And you can also do that when comparing the queries. And this time we have much more columns, so we can compare the first set of data with the second set of data. So duration 1, duration 2, and the difference between the two. And if I rank by difference in duration, this is what we have in case of regressions. So the queries that took longer in the target environment compared to the source environment. So if I order by difference in duration here, I get all the regression, and I could start tuning from here. So this is an alternative method to using query store to capture the regressions, because with query store, you need to get the queries to regress first in the production environment. But using this method, you can capture those regressions in the test environment before you hit production. So this is actually good. And well, let's go to the last example very quickly, because we only have a couple of minutes left. Oh, wait. What we can do here is running this replay in real time. How does it work? Instead of reading from a file, if I am reading my events from a production database directly, I don't need to write to a file. What I can do is take my events directly from production, use SQL workload to replay them in real time against the test database, and I can have SQL workload again in real time that takes the execution events from the test database and write the analysis data incrementally. So I can observe in real time how the two benchmark compare against each other. And I can show you that by using the real-time replay. So it looks pretty much the same, but in this case, for the real-time replay, I'm going to have to run, so start all again, run 2 CMDs. So the replay is not different. So replay CMD uses replay JSON, and replay JSON gets the events from a live database using extended events. And the consumer is the replay consumer. So it goes directly to my Azure SQL DB. And I am also writing to the analysis database. So this writes how the source workload looks like. And for the analyze, this is no different. It uses analyze JSON, and it's pointed to my Azure SQL DB, and the consumer is an analysis consumer. So this is not different, and it captures what the replay looks like. Good, so if I run these two, I will get again 2 instances of SQL workload. One is a replay, one is a analysis. So one on the left is a replay, and it's replaying the events in real time. Well, I would actually need to have a workload to do this. So, well, we don't have time for that. I can show you how this looks like when it runs for a while. And this is particularly useful when you need to capture a big workload that spans across weeks or months, and you cannot imagine doing that with capturing to a file, because the file would become huge and you would never get to analyze and replay them in a meaningful way. So having the real-time replay helps you in those situations. This is what it looks like. I have this running on a client of mine for several hours, and this is what it looks like. You have the source, so the baseline in green, and the target, the benchmark, in black, and you see how the two compare against each other. The source was a SQL 2008, and the target was a SQL 2017. And as you can see, we had some regressions like around here. So what we had to do was go here and inspect what the queries looked like here and get the regressions. Oh, this is bad, so I can go and tune this ones because this one really got much worse. So get the plans and compare the two, source and target, and see how to tune these queries. Good. So wrapping up, benchmarking used to be hard, but now with workload tools, it is easy as pie. All you have to do is configure a few environment options in a JSON file, and workload tools will take care of all the rest. I will leave you with some resources about workload tools. So the link to the project itself and the documentation. And if you run into bugs, just file an issue. And I have some blog posts on my blog that describe how to use workload tools. And here is a blog post that describes how to set up Azure Blob Storage to use it to capture extended events on there. And I think that's it. And if you have questions, make sure to send me an email if we don't have time to answer those right now.
So, Kianluca, that was a really nice session. I think you covered the entire, different tools that one should use, right? So that was really interesting. We'll take a couple of questions that have come from the comments quickly, if you can answer them. First one is from Bhaskar. He says, how SQL workload is different from traditional tools?
Good. It is different because, well, first of all, it can run against Azure. So you can use it to capture a workload on Azure SQL database or managed instance, which you cannot do with the traditional tools. And also it has the ability to run the replay in real time, which also you don't get with the traditional tools.
Yeah, that definitely makes sense. Yeah, it runs on Azure, so that's definitely helpful. We'll take one more. It's coming from your choice. He asks, which tool is best for capturing workloads, profilers, or extended events or SQL trace?
So whatever you can, use extended events because it's lighter on the target server, so on the server being observed. And if you are using an older version of SQL Server, like a 2008 or 2005, you can use SQL Trace. You have to use SQL Trace because you don't have extended events there.
All right, so that's it. Thank you so much, Gianluca. I hope I'm saying your name correctly. And that was a really great session. We will love to have you back when you have time next time. And until then, thank you so much and have a nice weekend ahead.
You too. Thanks for having me.
Bye.
Bye.
All right, so we now move to our next session that is on performance feature in SQL Server and Azure SQL. And that will be by, I just hope I say this right, Javier. I think, yeah, that's how we say it. Right? I'm having trouble with the Spanish names, right? So he is a Microsoft Data Platform MVP. He's an MCT. He's an IT director, and he specializes in administration, performance tuning, high availability, and disaster recovery. So let me go ahead and bring next speaker, Javier. Hi, Javier. Welcome to the SQL Server Virtual Conference.
Hi, Simon. How are you? Good day to you and to all the audience. It's a pleasure to be here today. Can you hear me well?
Yeah, your sound is crisp and your video looks perfect. And thank you actually for all that you do for the community. I see you're an MVP, so that definitely means you contribute a lot to the community. So as you're doing for this event, so thank you so much, Kibir. I won't take much of your time. It's already 5 minutes, 6 minutes above. So you can go ahead and start the share screen, and then we can get started.
All right, so let me share my screen then and see if you can see it. All right. So I'm kind of new to StreamYard, but screen share, share screen. I have to choose one. So you see it?
I see a screen. I have added it to the stream.
Ex-
Perfect. Next 45 minutes is all yours.
Sure, thanks. So let's start then. Okay, welcome everybody to this great event, this conference. I always love to be here presenting for the community, especially for this kind of events which has a purpose, right? So thank you for all the organizers to put it in place and, well, to have this awesome community. So let's start. Today, we will be talking about performance features in SQL Server and Azure SQL, right? Let's cover few of those new features, existing features, and hopefully all of you can learn something today to, go to your environments and start using it quickly. So a little bit about myself. My name is Javier Villegas. I am from Buenos Aires, Argentina. I work at Mediterranean Shipping Company as IT Director of Data and BI. I am Microsoft MVP and Microsoft Certified Trainer, and also a technical speaker which loves to participate in every single event that I can, right? On the left side of the screen, you have all my contact information, Twitter, LinkedIn, email, blog. So feel free to reach me for any question related to this presentation, or if you just want to do networking. All right, so let's start real quick. Let's see what we're going to be covering today. Basically, Microsoft is not supporting anymore SQL Server 2008 and R2, right? And SQL Server 2012, the extended maintenance, we are kind of, soon is going to be also off. So what Microsoft calls the modern version of SQL servers are basically 2016, 17, and 19. So in terms of SQL Server on-premise, let's focus on these three versions. We also going to be covering performance features in Azure SQL, right? So this new umbrella called Azure SQL, which covers a couple of things that we will go through the presentation. Nowadays, right, under this umbrella of Azure SQL, let's do the initial categories or let's say product/services that Microsoft defined for Azure SQL. First of all, in Azure, in the bucket of infrastructure as a service, we have virtual machines running same SQL Server version that we saw before, right? Since 2008 and 2008 R2 up to 2019 in any combination of operating systems, SQL Server version and edition, right? So this is kind of the same thing that we are used to in on-prem, right? But running on a virtual machine. Then in the category of platform as a service, right, we have two flavors. One is Azure SQL Managed Instance, right? This is a managed SQL Server service that Microsoft give us, in where the only thing we need to do It just connect to the SQL Server endpoint with Management Studio, with Visual Studio, or any other tool that we use to connect. This is quite similar to what we know about SQL Server, right? So the footprint in terms of features, connectivities, and any kind of usage is quite similar, not 100%, but quite similar to SQL Server. And then we have Azure SQL Database, which is the modern version of SQL Server, which again has a lot of things in common with SQL Server, but it's more targeted to a specific scenario, which is called modern application, right? So in this conversation, we won't go deeper on what Azure SQL Database is, but it's one of the flavors that we have in the Azure SQL family. Again, nowadays, SQL Server runs everywhere. I remember on my beginnings in where the only platform that was Windows Server running on Intel AMD processors and SQL Server 6, 6.5, etc. But nowadays, we can say that SQL Server is everywhere. So we have SQL Server running in Windows environment, in bare metal servers. Since SQL Server 2017, Microsoft gave us the possibility of running SQL Server in Linux, major Linux distributions like SUSE, Red Hat, or Ubuntu. And in parallel, we also have the possibility of running SQL Server in containers and also under Kubernetes if we need to orchestrate a bunch of containers with SQL Server. Additionally, on the cloud, or in this particular case, Azure environment, we have, as we mentioned before, the virtual machines. We also have managed instance, as we said, and Azure SQL Database. And then, finally, we also have the possibility of running SQL Server on Edge. Basically, this is SQL Server running on ARM devices, right? Like a Raspberry Pi, in where you have a very common footprint of your SQL Server environment. Of course, you won't be running your critical workload, your mission critical environment in one of these devices. But for certain scenarios, specifically on Edge, right, is a great option. So going deeper to performance, right, we know some of the capabilities and tasks that we may need to consider when we do performance tuning and troubleshooting, right? We know that we definitely need to take care about memory, CPU, and I/O, right? Those are the three major pillars of SQL Server. We have indexes, partition in memory, most recently, and also we have something that is called intelligent performance. We're going to be covering that in a minute. There are also certain tasks that we always need to take care of, like maintenance, right? So definitely our SQL Server required us as DBAs to schedule and prepare certain maintenance activities that we need to do on a specific environment. In the Azure SQL world, right, this hasn't changed much, right? As Microsoft called this Azure SQL, it's just SQL, right? So all that we learned over the past many years applies on Azure SQL, right? So we need to take care of CPU, memory, and I/O, right? We have to handle indexes, maintenance, partitions, and we have this particular thing called intelligent performance that we're going to cover. When we need to configure an environment for achieving performance, we can talk about any production environment, right? We know that there are certain things that we always have to take care of, like 10DB, right? There are multiple articles, and we can discuss for hours about TenDB, but there are certain rules that apply for TenDB. In terms of Azure SQL, we need to consider that the recovery model in Azure SQL is only full, right? So this is something that for certain performance operation, I mean, just knowing that we have to deal with that is enough, right? We don't have simple recovery model. We also have, to deal with files and files groups. It's a little bit different than what we know on premise. The whole I/O thing is a little bit more complicated. Not complicated. There are more things that we may need to consider, right? This is not the same storage that we know how to deal with in an on-premise environment, but definitely there are a bunch of things in common. And of course, MaxDOP, again, we can talk for hours. Also, resource governor, right? We can define resource governors to, give and assign certain set of resources for a particular type of workload, right? In terms of monitoring and troubleshooting, this is kind of all the things that we always know, right? But we have some additions in Azure SQL. Definitely, we have the DMVs, right? The dynamic management views, in where SQL Server give us a ton of feedback for us to understand what's going on, and basically to do monitoring, troubleshooting, and also be proactive in certain areas to avoid future performance problems, right? In Azure, we have the different type of metrics that we can monitor directly through the Azure portal. We also gonna be covering specifically Query Store, which is one of the features that I like a lot, and it's a game changer, believe me. So then, we will see this in action in a few minutes. In terms of DMVs, right, for managed instance and Azure SQL database, we have all the ones we know, right? But there are certain cases that, not cases, there are additional DMVs for each of them, which are specifically for points related to SQL Server as a service, right? We have the list in here. If you all use extended events, something that we definitely should be using heavily these days, right? We also have the possibility of configuring extended event sessions in managed instance and Azure SQL database. The main difference is that the target, right? Since this is a managed service, we don't have access to the file system. The target will be on Azure Blob Storage, right? So definitely we can do and create and configure our sessions, right? And the target will be on a Blob Storage. So let's go deeply to these features that we're going to be covering. As I mentioned at the beginning, this is mostly based on modern SQL Server versions since SQL Server 2016. On SQL Server 2016, Microsoft released this feature, which was a kind of a game changer, is Query Store. And what is Query Store? Basically, will help us to keep track of a bunch of things, right, which will allow us at the end to accomplish good performance. And with what do I mean with good performance? We're coming from older SQL Server version, and we all know that one day you can have your critical report running, right? Normally runs for, let's say, 20 minutes, and early in the morning you have your output in your desktop, right? That particular day, something happened, right? And that report is running kind of forever. Right? So, besides having good performance fast execution and low resource usage, we also need to maintain that performance level over time, right, on a better way. And this is what Microsoft is targeting these days with this set of features, right? So we're going to be covering query store, automatic query tuning, adaptive query processing, which later turns into intelligent query processing, right? We're going to check something about in memory, and also this feature called 10dB metadata. So this intelligent performance basically is based on the concept of, while our workload runs, SQL Server collects information about this and give us the possibility of adjusting the performance on the fly, setting specifically certain specific topics, like for example in query store, and we're going to see, or eventually in an automatic way, right? So what is query store? A bunch of people define this, and I like this definition, as the flight recorder of our user databases, right? So with query store, which by the way is disabled in SQL Server on-premise, but is enabled by default in Azure SQL, right? We can turn it on for a specific user database, and what we're going to be doing is basically capturing all the execution statistic, plan changes, resource usage, and then in 2017, Microsoft also added the possibility of keep tracking of the wait stats, right? So what can we do with this? Okay, we can have SQL Server monitoring all the activity on that particular database, and from a very nice dashboard, we can see, every single query, right, that is running in our server, right, with all the statistics like that they have. For example, we have one of the report, which is the queries with regressions, or the top heaviest queries in our system, right? So with that, we can see for each of them the amount of resource usage, the amount of time that was running, usage of reads, writes, etc., etc. And how this works internally. Basically, when SQL Server has to compile, we execute a statement, a store procedure, something in our SQL environment. What we have is SQL Server beside the compilation send a message to the query store. So it's going to store internally in this flight recorder, right, all the plan, right? Then it will execute the query, right, as we normally do, and then it will send again another message to query store to keep track of all the execution stats, right? And where does SQL store all this information? Well, basically within the same user database, right? So from Management Studio or from SQL, we can enable query store, right, and define an amount of, a space, certain amount of gigabytes to be allocated on the same user database to store query store information, right? So it's quite simple to enable, quite simple to use it, and definitely, it gives us a lot of, feedback to do performance troubleshooting and tuning, right? This is what we're going to be seeing from Management Studio, all these reports, and we're going to see it in action in a minute. And what is one of the beauties that we have with Query Store? For that case that I mentioned, that the report is normally running in a certain amount of time, and suddenly the execution time change, right? One of the most common, possibilities is that the plan has changed and the new plan is not ideal, I would say, or is not as good as the previous one. So we have more usage of resources and more execution time. From Management Studio, right, we can decide and manually force to use, for a particular store procedure or statement, we can manually force to use a previous execution plan. So then from that point onward, right, SQL Server will rely on the plan that you force to use, right? And eventually come back to the previous execution time and type of usage. So there are certain cases in where we need to use query store. Like, for example, when we do a migration, right? When we do a migration, definitely it's a good thing to see if we have regressions in our workload, and easily we can detect it with query store. Also, if you definitely have a very busy environment, it's good to keep track of all these activities, these statistics for you to understand what's going on and, eventually tune it and get better resource usage. So here are a set of best practices in using query store. Definitely important to follow, right? And also know that if you are enabling a query store in a very busy transactional environment, right, there is a list of things that you have to consider, and eventually enabling some trace flags, right? So again, it's as simple as enabling the query store, but again, that is if you want just to play. But if you're going to be doing it in a busy environment, well, it's good to take a look on these best practices so you can use it in the right way. So excellent. I love query store. But what happened in that case in where we have the regression in the middle of the night, right? So nobody goes to our server again until 8 in the morning. We're going to have this regression, right, during the whole night. And then when the DBA arrives to the office, 8 a.m., it's going to be notified, right, and manually going to force the execution plan to, be the previous one and go back to a reasonable performance. So with that, Microsoft on SQL Server 2017 has released another feature called automatic query tuning, which basically works at the top of query store. And what can you do with automatic query tuning? Basically, if you have query store enabled and you have automatic query tune enabled for this particular user database, if automatic query tuning detects that one session, one procedure, or one statement, right, has a regression, automatically will set the last known good plan, right? That means that without us doing anything, right, even if it happened at 2, 3 a.m. in the morning, it will force to use the last known good plan, right? This is really awesome, and I use it a lot, right? So with that, you can have automatic plan correction on the fly, right, without you taking care of forcing the plans, right? In Azure SQL Database, right, there is an additional feature which also allows the automatic query tuning to drop and create indexes on the fly. So if it detects that there is a missing index for a particular type of procedure statement, right, if you enable it, right, it can create the missing indexes on the fly for you, right, and then eventually it can drop those indexes when they are not used anymore. So again, you can consider that or rely on that on Azure SQL data, right? So definitely automatic query tuning will help us, especially the DBA, to do this kind of task, and also to achieve what Microsoft is focusing a lot these days, is giving us good performance, stable performance without doing code change. You will see that, till here and from now on, right, I haven't mentioned about going to store procedure and rewriting it or adjusting it or doing anything. No, all this works on our existing code without any changes, right? So how this automatic query tuning works? Well, basically continuously learns what is going on using the query store repository. It adapts the workload by manually forcing to the last known good plan, then do a verification that the new plan is in fact working better, and then repeat, right? Learning, adapt, and verify. So definitely is something that in several cases is quite important to use. So we mentioned this before about the plan regressions, right? And most probably all of us have seen this in the past, right? Something running with a particular plan, and then suddenly the plan change, right? So with automatic plan correction, what we can have here is the possibility of going back to a previous plan. We're going to see it in action in a minute. Then also in SQL Server 2017, Microsoft has introduced this new feature called adaptive query processing, right? And basically, this was the first approach to do something that to me is really good, because we all know that when SQL Server compiles the plan, it's going to use that plan, right, as an static plan from the cache, right, and then eventually it's going to change it for any reason, right? With this, right, with this feature, Microsoft, on certain circumstances, will adjust the plan, providing certain feedback, right, to use it in the proper way, right? So definitely, again, without any code change, we can do certain things like, adjusting the performance on the fly. So what was adaptive query processing back in 2017, right? This was this superset of features that includes batch mode, memory grant feedback, batch mode, adaptive join, and interleave executions, right? So basically, again, the concept is that for certain, operations within the engine, it was executing, adjusting, the plan on the fly to get better performance. Right? And let's going to focus in a couple of them. For example, memory grant feedback is one that I like and I see in action a lot. For example, let's say that you have this process that when SQL Server compiled it for the very first time, SQL Server granted certain amount of memory, let's say 10 megabytes. Very good. Then you execute the query and you ended up using 1 megabyte instead of 10. Well, you can say, all right, that is not a problem. I have 10 megabyte granted and I'm only using 1. So my workload is going to run okay. But what about if that particular procedure is being executed hundreds of times per minute, right? You're going to be allocating several, chunks of 10 megabytes and using only 10%. And that's going to affect not only that particular workload, but all the overall performance for the instance. And then you have the other possibility. If SQL Server, grant 10 megabyte, but then, when the subsequent execution, it's ended up using 20 megabytes, right? It's going to be spilling to 10 dB. And we all know what's happened when you do the 10 dB. Performance is terrible or goes down. So this is something that Microsoft now can address with the memory grant feedback. And then adaptive join. Again, we're going to see now a new operator within the execution plans, right? That basically will choose one type of join or the other, depending on the branch of each of the joins, to see how many rows are returning, right? So depending the amount of row returning from each of the branch, it will use one type of join or the other, right? Then in SQL Server 2019, Microsoft added a superset of feature, right? And instead of calling adaptive query processing, it just call it intelligent query processing, right? Which, if you see the slide, right, the ones that are in regular letters are the ones that were coming from 2017, and the ones in bold letters are the ones in SQL Server 2019. Many more than before, right? We also have the memory grant feedback, but initially in 2017 was only in batch mode. Now it's also available in row mode, right? This is in SQL Server 2019, right? Again, the one in regular 2017, the one in bold, or actually all of them in 2019. We also have the adaptive join, the interleave execution, right? And then we have one that is really nice, actually, which is scalar UDF inlining. We all know that SQL Server historically had a bunch of problems dealing with a scalar function, right? Because of the execution plan was not considering like a heavy thing. But we all have seen a bunch of developers being so creative and adding a ton of business logic within this scalar UDF inlining function. So now we're going to see that with intelligent query processing, Microsoft basically goes and checks and compiles the UDF and then put it back into the main execution plan. And then another feature really nice, which is approximate count distinct, right? Is basically gives you the possibility, if you have a table with several million rows, right? And you have to do a select count distinct, right? We know that's definitely going to be a lengthy operation. It's going to use a ton of resources in terms of memory, right? And you're going to get the exact value of the count distinct. Now, in 2019, there is this new command called approximate count distinct that will use a fraction of this execution time and resources, right? And it's going to give you an approximate value. Microsoft said that around the 3% of variation. Of course, this is not useful for a financial workload. But there are certain workloads, like, for example, imagine that you need to fill up one chart in a Power BI report, right? Having a difference of 2-3% is not going to be a big deal, and you're going to get the result quite quickly. We will see it later. So how do we use all these features that now we know that they are there and we want to use them? Well, basically, the only thing we need to do is change the compatibility level of our user database to 140 if it is 2017 or 150 for 2019, right? So you know that Microsoft is focusing now on having everything encapsulated on a user database, so you can have a set of features per user database, also including database scope configuration, in where you can turn on and off several sets or settings for a particular user database. Also, in terms of performance features, or actually we can use it, to help us with monitoring performance, Microsoft has released lightweight query profiling, right? Again, let's consider that we have this workload running forever, and we have to take a decision. It's running, so do we wait till it finish? What do? We don't know what part of the execution is at, right? So, for example, we don't know if it is at 10%, is at half of the execution, or about to end. Knowing that, we will have better information to take our decision, right? Well, now in SQL Server 2019, Microsoft has released this lightweight query profiling, which basically, for every single process running on your server, right, you're gonna get the estimated query progress. So you're gonna see if it is at 10%, 50%, 90%. So you will see all the execution progress in an estimated way, right? So knowing that information, you can take better decisions. This is, as I said, a feature which is enabled by default in SQL Server 2019. Something very good that Microsoft has done is that they port this feature back to 2017 and 2016 Service Pack 1, right? So if we have 2017 or 2016 Service Pack 1 onward, right, we can use lightweight query profiling. As per compatibility, right, Microsoft is keeping it disabled by default, right? So if you want to use it, you have to enable the trace flag 7412, right? Again, in 2019, it comes enabled by default. And then, the TemDB metadata feature, right? This is SQL Server 2019, which, give us the possibility of creating, or when we have this feature enabled, all the metadata for the user objects that we store on TemDB, right, will go to memory. This is similar to the in-memory OLTP technology, right, that we have from many SQL Server versions now, but for TemDB. That doesn't mean that if we create a sharp table, right, everything's going to go to memory and it's not going to be touching the TemDB, right? No, the metadata of those objects will go into memory. And with that, for certain kind of workload that requires, let's say we have a store procedure that we execute multiple times, right? And within the store procedure, we are creating and dropping objects quite often in a high rate, right? For those kind of workload, this feature is going to be really useful, because we won't have the latch of dropping and creating objects on the TemDB with all that means, right? All that is going to be in memory, so no latches, right? That doesn't mean that we don't have to tune our TemDB with, certain amount of files per core, etc. All the things that we know on how to tune TemDB, right? All that stays there. So, demo time. Let's see how all this works, right? Let's see it in action. So, here I have a virtual machine running SQL Server 2019, right? And we will start with lightweight query profiling, right? So I will have here include live query statistics. I will execute this. And when we see the plan, right, note here that at the top we have the estimated query progress, right? Is in this case 61%. And this is dynamic, it keeps moving. So let's execute this other one, right? And you will see how this keeps moving, right? So this one was quite fast. So let's do it one more time. You see how the estimated query progress is moving. And also we see it here at the bottom, right? So here and here. So this is really nice and good. But you can tell me, this is great, but I don't run my workload from Management Studio. I have middle tiers, web servers, application servers that are hitting my server constantly. All right, for that we have, let's have I have here one batch file which basically creates random activity on my SQL Server instance. So it's just executing a bunch of stuff. So let's minimize it for a minute. So then I go to Management Studio, I do right click on my server, and here we have the activity monitor. So when I go to activity monitor, for the ones that don't know, activity monitor basically gives you a real-time monitoring solution from within Management Studio, which give you in real time processor time, waits, IOPS, and batch requests per second. So you can see it in action. It's going to take a second to populate all this for the very first time. And then you can have details of those processes, etc. The last one is saying active expensive queries. So if we expand here, we see all these statements that are running against my instance, right? So we see the heaviest one. Well, this is configuring Azure, so it's doing certain backups. Remember, we have here the workload running. So in 1 second, we're going to see this activity in here. All right. So let's wait for the next refresh. Okay, here we're going to capture one of these, and here note that we see show live execution plan. So when we go here, we see the plan, we see the execution live, and again, we have the estimated query progress. So we see all the activity coming from my application server, right, here, and we see at which point of the execution is at. So really, really nice. So let's switch to something else. Then we have query store, right? Let's see how query store works. First of all, here I drop and recreate a new user database, right? I create a new table with 3 columns, C1, C2, and C3. Then I create the store procedure, which basically does a select statement on that table, right? And then I did an insert of pseudo random values to these tables. And finally, I just enable query store, right? If we do select here, I did it in advance because this takes a little bit, but we have the user database ready. So if I do the select, I see all the data. So let's execute that store procedure 20 times, right? So we execute the store procedure 20 times. We go to Management Studio. We go to the database that we created here. And under Query Store, we can see top resource consuming queries, right? So when we got here, we see our only query, right? This is the only query running on my server. And here we have the execution plan. We can also put it in a grid. We see that it was executed 20 times with a minimum duration of 2.8 and a maximum of 4.48, right? Okay, so let's go back here. And what I will do is I will create a non-clustered index on the column C3, right? This is on table that we have. And I will execute my store procedure another 20 times, right? When I go back to query store, right?
Xavier, I think if you would like to wrap in another 2 or 3 minutes.
Okay. So here, we see that now we have an additional plan, right? We can run it one more time with a new index and also execute it 20 times, right? When we see that and we refresh, we'll see that we have now an additional plan, right? So we see all the execution, we see the plan change. Eventually, if for any reason, let's say we want to use this plan, we just go here and we force to use this particular plan, right? So to end up, I will do the demo of automatic query tuning, right? Here, I have a demo which basically is executing certain workload in my user database, right? So it's executing. Let me do a quick change here on scale. Okay, so we have here batch requests per second, right? And we have a number of around 100, right? So what I will do here, let me clear this. I will enter a regression, right? So now my workload has a regression and the and it is decreasing, right? So now what we can do is basically go to query store and force to use the last one. But if instead we just go and do this, right, for my user database, right, I'm going to be just doing enabling automatic query tuning, forcing the last known good plan, right? And that's going to make the job for us. On the upcoming execution, if it detects the regression, it will manually fix it. Finally, let me do this one, right? This one, what we're going to see the intelligent query processing. What we have here, I'm going to do only one example, the memory grant feedback. I'm changing the compatibility level, creating a store procedure, which is doing a bunch of joins, right? And what I'm doing here is executing the store procedure for the very first time with one parameter, parameter 8, right? No rows return it, and when we go to the execution plan, we see the warning here that we have an excessive grant, right? When we run it with the different parameters, so it's going to be using the plan that is in cache, right? We will see that it's taking several seconds, 5 seconds, and it returns certain amount of rows. And if we go to the plan, we see these warnings everywhere, right? Spilling of 10 dB, grant, etc. Let's see what happens if we execute it one more time. First of all, it took 2 seconds instead of 6. When we go back to the execution plan, we don't see those warnings anymore. They are gone, right? And this is because the intelligent query processing has adjusted the memory grant feedback on the fly for us. So let me go back to presentation. All right, this is a quote from Past Summit 2019 that we as Mediterranean Shipping Company has made on these new features, right? We use them very heavily. Finally, if you want to learn more about SQL Server 2019, you have these links to follow, right? Also for Azure Fundamental, to keep learning, I will publish the slide in a minute in my GitHub repository, and will send the link through Twitter, right? And with that, I just want to thank you. We don't have time for questions. Again, you can reach me from Twitter, LinkedIn, email if you want to discuss further. So, Simon, thank you so much.
Yeah, okay, well, that was a really amazing session. Thank you so much for your time. We're running a little late over time, but that was a really good presentation. You covered the entire ecosystem, right? So really well. I hope this will be helpful when people go ahead and watch it when it's archived. So thank you so much, Javier. I hope there was one comment that said, how do you say your name? If you could just help with that. So how do you go ahead and pronounce your name? There was one just comment. Oh my goodness, what's it's not good.
All right.
So there's just one comment coming in. So that's it. Okay, thank you so much for your time, and we'll see you next week. Have a nice weekend.
You too. Bye.
All right. So with that, we move to our next session. That is by Kathy. She's going to talk about modern T-SQL for better performance. And Kathy is a data platform MVP and editor of Simple Talk at Redgate. She has worked with SQL Server for over 20 years and has authored, co-authored, or tech-edited over a dozen of technical books. She's a co-founder of the Past Women in Technology Virtual Group and volunteer at Launch Code. And also, Redgate is one of the sponsors for our event. They have a new product that is Redgate Deploy. I have given the link in the comments. You can always go ahead and check that. So with that, any further ado, let's go and invite Kathy.
See my screen yet and everything?
Hi, Kathy. Welcome to the SQL Server Virtual Conference.
Hello. Thank you for having me.
I'm really sorry
You
for
ready
for
for
the
me to
delay.
get going?
Sorry?
Okay. Okay, so I have, what time do I need to stop?
Okay, so take your time. If it's 15 minutes, it's all yours, right? Next 15 minutes is all yours. Not a problem.
Okay.
All right,
Okay,
so I have your
thank you so
screen
much.
shared. You can...
Okay, hello everybody. I'm Kathy Kellenberger, and I am not going to worry too much about this screen because I know that you just had an introduction about me. However, the important thing to know about me is that I'm a lifelong teacher and lifelong learner and teacher, and I just love sharing knowledge with everyone about what I've learned about SQL Server. Here's my agenda, but I'm going to tell you a little bit about the background of why I came up with this session. It's because starting with 2005, I would always put together a session talking about all the new T-SQL features of every edition. So every edition that would come out, I would have a talk. When I got to 2012, there were so many new features, and I discovered a set of functions called windowing functions. And I just started concentrating on that. And that One session ended up being 2 sessions, ended up being a book, ended up being a Pluralsight course. And if you've seen me speaking in the past, you have probably seen me talk on windowing functions. That's not what this is completely about today, but I thought about how people kind of get stuck doing the same things over and over again. Solving problems the same way. And I get it. You're busy. You've got to solve a problem and you do it the way you know how. And when I've been out presenting on windowing functions or a lot of the other new functions, almost everyone in the room has never heard of them. So I thought this was a nice way to show not concentrating on a group of functions, but just a way to show how to solve some problems that might be similar to those that you come up with. Since this is 50 minutes, I'm going to say the last little section that I usually talk about will be bonus. If I get to that, I'll cover it. If not, then I just won't worry about it today, just because it is 50 minutes. All right, so we do get stuck doing what we know works. That might be something like a cursor. To me, a cursor is another tool in your toolbox. There's the rare case where that's the right answer. Maybe you have a cursor that reads a list of user accounts and does something with those accounts. That makes sense. But typically to solve a T-SQL problem, that's not the right answer. It's probably going to be slow. It's probably not going to scale, but that might be the most logical way that you come up with when you're trying to solve it. Sometimes there's things that can be solved with self-joins, and you get this really great solution, and it looks, it's pretty complex, and you're really proud of yourself for doing it. But you know what? It might not be a good way to solve a problem. There might be something that's much better that is available that you don't know about. Another one, it's really a red flag for me, are scalar UDFs. A lot of places use these to reuse formulas. A lot of times these are not going to scale. I don't know if I'll get to talking about this particular item because that is in the intelligent query processing at the end, but just in case. So the first problem is called the stock market problem. Back when I was a consultant, a DBA came to me. I was working on an ETL project, and the DBA came to me and said, I pull data from the stock market every night, and I want to compare the closing price of one day for a stock with the closing price of another day. I think you can help me solve that query. So I did. Then a few months later, a junior consultant who I was mentoring came to me and said, hey, I pull data from the stock market every night. I have an ETL process that loads it into a table. I want to compare the closing price from one day to the closing price of the next. How do I do that? So you may think I'm making this up, but this is exactly what happened. So I'm going to show you how that problem was solved. Oh, wait, before I do it, I am going to show you what the data looks. Not quite ready to go to the, this is what, I want to show you this first. So I have lots of symbols, and my data is all made up. Obviously, these are real dates, fake ticker symbols, fake prices. So if I have ticker symbol Z1, and on the second date, if I want to compare these, I got to pull this earlier one forward, okay? And so on. And if I get to a new ticker symbol, I don't want to pull a value from the previous one. All right, I think I'm now ready to go to the demo. And let's see. Yep, that's it. All right, so I have created this stock history table, and my slides are available. My slides and code are available out of my GitHub. I don't have a link to that here, but I'll also send it to the organizers as well. But you can create this table. So you can see that you've got all these different symbols. There's almost 700,000 rows in this table. So it's going to be kind of a lot of work to compare one to another. So the first thing I might try to do to try to figure this out is do a self-join. I might say, well, I got to join the stock history table to itself based on the symbol, and then where the one trade date is greater than the other. I might do this, but it would not work because I'm really kind of creating a Cartesian product here. I'm going to stop it. You can see that this is not working. And the problem is I'm pulling all the dates from B, not just the one date that I need. So that doesn't work at all. I'm going to go ahead and run this for a few seconds because it will populate my little temp table here. So I could do something like this. And I'm just going to let it run for about 10 seconds because I'm not going to sit here for a couple of minutes. Actually, even a couple of minutes only processed over 2,000 rows, not the 700,000. Okay, I'm going to stop that. Since it populates one stock day, one ticker day per run, I will have some data in my stock table, in my temp table. And I just have 116 rows processed, but you can see that it did work. So this solution does work. And maybe it might make sense if you were going to just run the new values every night. That wouldn't take too long. It might be a viable solution. But if you got to run the whole thing, forget it. It's going to take, I don't know, maybe an hour. All right, so there's an operator called apply where we can, basically select top one. So we can use that same join, this outer query to the inner query, join on ticker symbol where the trade date is less than the outer trade date. I've got this filtered just to run a few. You go ahead and run that. Not sure how long it will take. This will work. And it ran in 5 seconds, but I only tested 4 symbols, not several hundred like I've got. And it did work. So that is a possible solution, but it's still slow. So here's the best solution. There is a function called lag, and it's one of the windowing functions that was introduced in 2012. So don't worry too much about the syntax. Either find a recording of me talking about this out there, or I have a book on windowing functions. It's Ben's Gone has a book as well. And of course, there's Microsoft documentation. But basically what's going on is I'm using lag to grab a column from a previous row. I use the over clause to explain to lag how I want the data lined up and that I don't want to cross ticker symbols. And you can see that this works. And it's really fast. I ran the entire data set in 9 seconds and got the right answer. I love lag. It is my absolute favorite function. And let's go back to the slides. There we go. So there's also one called lead that lets you go forward in the data set. This is just some other information about it that I just kind of went over during the demo. So I'm going to move on. And I guess we can save, if there's time, I'll save questions for the end. The next one is an interesting problem. You may remember getting some publications like this delivered to your house on a weekly or monthly basis. Magazine subscriptions. I still get one just because I like to just kind of sit and, read it when I want to get away from a computer. The subscription problem was originally from SQL Server Central, and it was part of what was called the Speed Freakery contest. With this contest, SQL Server Central supplied a set of data, a cursor solution, and then a prize to whoever could get this to run, get the solution, get a new solution to run the fastest. The cursor solution was supplied so that the contestants knew that they were getting the right answer. So here's an example of what it might look like. I've got a registration ID. I got a date that they joined, started getting the subscription, and also the date that they left. So for every month, I don't care when they joined during the month, but for every month, how many subscriptions are current? So what you'd have to do is take the previous number of subscriptions, add how many joined that month, and subtract how many left. And you'd get an answer something like this. Okay, so I'm going to pop over to the slides again, to the demo again, and let's take a look at how this works. So here's this. The original problem was from back in 2008 or 9, before SQL Server 2012 came out. So a little bit more about the background that I forgot to say is that the guru solutions that the people that won the contest were so hard to understand that Redgate at the time, and I wasn't working for them back then, approached me and said, can you write an article explaining this solution? So I did that. And then when 2012 came out, I said, hey, wait a minute, there's all these new functions. Maybe they will make solving this problem easier. So I went back and revisited several of those contests. So I did not enter the original contest, but I was able to eventually, with a lot of study and experimentation, understand the solutions by the gurus and explain them. So here's the data. So one thing I will say is that for the time period, which is about 30 years, every month has people joining. There are some months that do not have people left, and that does make a difference in the solution. So the original problem back in the late 2000s only had 10,000 rows. I had to bump this up to 1 million rows to make it worth it on my newer laptop, okay, that's pretty beefy. And so let me just show you that we do have 1 million rows. And part of it is that hardware has just improved a lot over the last 12 years or so. So one thing that I can do is take this data and I can break it down and say, okay, here's my registrations each month, here's my unsubscribes each month, and then I can work with that. So just doing that makes the problem easier. And that's the basis of all the solutions. Okay, there's a lot of ways we could solve this. In this case, I've taken the joins and the lefts and put them in common table expressions. Then I join together, and then in the outer query, I use a correlated subquery to do my running total. It's basically a running total solution. I mean, this will work, but it does take a very, very long time to run. This is not the guru. I don't have the guru solution in here. I'm going to go ahead and stop this because it would take too long. The guru solution did something called a quirky update. And if you go out and do a search for that, you might find it. It was a very odd solution but ran very fast. So here was the solution that was given to the contestants. And go ahead and just run that for a few seconds. I don't want to run the whole thing. I'll just run it for about 10 seconds. Oh, it actually ran fast. Isn't that crazy? Sometimes it runs fast for me and sometimes it doesn't. Depends on, I guess, what else is going on my laptop. And there's the report. So even on 1 million rows, the cursor solution ran pretty fast. But it doesn't always. So I guess it depends. So this is the modern solution that I came up with in 2012. Again, I have got a common table expression for the new subscription, a common table expression for the cancellations. I'm also using this thing called EO month. And let's go back and look at what I was doing back here. I was breaking the data apart and putting it back together for the first of the month, because I had to normalize the date in some way because we had dates all over. We just wanted to standardize on the month. I'll talk more about this function in the next section. So let's go ahead and run that. Again, I've got my new subscriptions, my cancellations, and in the outer query, I am joining those together on the date. And I'm doing something interesting. I'm doing the sum. Let me go ahead and run it. But I'm doing that, and it ran very quickly. I'm doing the sum of the people joined, subtracting the people left. That makes sense. And it's also followed by this thing called the over clause, which you saw in the last section. An over clause with an order by. So I'm telling SQL Server I want a running total, and I'm also using this thing called a frame to tell SQL Server how I want these lines to roll up and how I want things to be added up or counted. You can also use this to do something like a moving average. Previous to 2020, a lot of people had not heard of moving averages unless they were working with financial information, financial data. And now I see a moving average every day from my local county health department, the moving average of positive percent of positive tests. So they could be, I don't know how they're calculating it. They could be using something like this, just changed up a bit. So that's how to solve that problem. And to me, it's easier even than writing a cursor. I just have to understand this windowing function here, window aggregate, I like to call it. So I'm going to go back to the slides. And again, this is new with SQL Server 2012. It will work if you don't add this frame. For regular running total, it will work. However, the performance could degrade if you don't do that. The next one I want to talk about, kind of look at that end of month problem. And it's part of a bunch of functions called I don't know, I made it up, the easy functions. And some of these I think were around 2008, some of them 2012. And some of them perform well if you only have a handful of rows. Some scale pretty well. So one of the things that I changed about that last section is that I used the function called EO month instead of splitting the data apart and putting it back together. So I found that it scaled really well. It was much better to use the EO month function than to tear the data apart and put it together. Some of the other easy functions don't scale quite as well. And let's say, so one of them, there's a string split where you can take a comma delimited list. Let's say it's from reporting services and you're sending a comma delimited list over to a stored procedure and you've got to split those out. there's a lot of ways to do that. There's the XML way, which I absolutely hate because it's so hard to write. There's a way where you could create a little function and loop through looking for the commas and send back a table. Or you could use string split. String split evidently doesn't scale very well. However, if you're just using it on 10, 20, 30 items, you know, it doesn't matter if it scales or not because that's just a little bit of data. So it makes things easy. Let me just go ahead and I feel like I'm really zipping through these because I haven't stopped for questions, but I'll stop for questions at the end. Okay, EO month. I'm not going to give a demo on all of these, but here's some of them that I was playing around with. There's one called IIF, which is a kind of like a case where you only have two options. And I think some of these were things that came from like either Excel or Access or other programming languages, and possibly just to make it easier to convert code into T-SQL. Concat is one of my absolute favorites, and I will show you a little bit about that. There's a format function where you can format dates exactly how you want. I don't think that one really scales too well. The string split that I mentioned, EO month, and there's several others. These are kind of the ones that I'm interested in. So if I look at, just to show you Concat, if you haven't heard of it, let's say, let me do something here. I am gonna comment that out for a minute. If I would try to run this, I will get a bunch of nulls because there are many names that don't have a middle name. Middle name is null, so they drop out. So by using, let me get that back in here, and I'm going to forget business entity ID for just a minute. If I try to run that with this new concat function, concat takes care of the nulls for me. So that's one thing I really, really love. It takes care of the nulls for me. So I might want to do something like add a space in there, something like that. Might want to do something like that. The other thing that concat is fantastic for, I'm going to go ahead and just copy that and paste it. If I wanted to add the business entity ID, just add it in both places. Obviously, this is not going to work because I can't add business entity ID because it's an integer. So I get this conversion failed. Okay, so let me just get rid of that piece because that's not going to work. But I can do it with concat, and concat will take care of my conversions for me. So that's why I really, really love it. And I did find that it scaled pretty well. So obviously, your mileage may vary. Here's the breaking a date apart. If I want to break a date apart to get the end of the month, here's a way I might do that. You know, I've got a couple date ads there. I'm casting. It's really, really messy. In order to really show the difference here, I'm using a different table. This is from Adam Mechanic. You may have heard of him. He has this script. He also has SP, who is active, but that's what he's most famous for. But he also has this Thinking Big Adventure table, which you can go out and download and run. So I like to use his tables often just when I'm working with performance, just because there's quite a few rows. And in this case, I created a smaller copy of the table. So what I'm going to do is I'm going to see how long it takes to populate this EO month temp table, and I'm doing it as a temp table just so it doesn't take long to populate the grid. I just want it to take its time doing the calculation, and I don't want to take time on this. And it is taking, there, but 12 seconds. So 12 seconds to populate almost 8 million rows. And we'll see that it did work. There's my new date. I'm going to go ahead and drop clean buffers to clean out the cache, make sure I'm not cheating. And I'm going to do this again, but this time I'm going to do the EO month function. And what I've found is it is a lot faster. Before it took 12 seconds, this time it took 5. So that's pretty good. It took half the time. So I am pretty confident that this EO month function is better than tearing the date apart and putting the date back together. And I'll run this just to show you that it did work, and it did. Okay, so what would happen if I would like to run it on the original big transaction history table that's got 31 million rows? Let's see how that does. Obviously, it's going to take more than 5 seconds, but let's take a look and see. So we are up to 5 seconds. I'm hoping it doesn't take any longer than 20. Up to 12 seconds, which is what the original code took to run just the 7 million rows. And it took 19 seconds. I was thinking around 20. So it took 19 seconds to operate on 31 million rows. And it did work. Okay, so this is just another example I had where I was doing that concat to show. I'm not going to worry about going through that because I just showed you an earlier one that worked. But I did some timings on some of these just to see. I'm not going to go through all of those. And you can experiment yourself. So if you want to use any of those new easy functions, make sure you do some testing first to make sure that you get the performance that you need. All right. Maybe I should stop to see if there's any questions. Simon, can you check to see? Or are we leaving them all to the end?
I think, Kathy, there's one.
Steve.
Oscar, he says, do you recommend learning T-SQL on the road towards data science? It's a kind of generic question. Okay, please say it again. Do you recommend learning T-SQL on the road toward data science? Yes, definitely. Definitely. If not T-SQL, SQL in general, because as if you're learning data science, you're not just going to be handed perfect data, okay? You may be needing to get data from lots of different systems, all right? And so definitely learn SQL. It doesn't necessarily have to be T-SQL, which is SQL Server's flavor of SQL. Just make sure that you're familiar with at least the SQL language from one vendor. And it's really easy to carry over to others because chances are you'll be pulling data from multiple systems. So that's a fantastic question. And what's really cool is I was just recently asked to help. There's a program that I teach, in St. Louis, and I was just asked to be a guest teacher on some of the analytics and data science sections. So make sure that they get that. So fantastic question. Is that the only question so far? Yeah, Kathy, we're good to go. Okay, fantastic. So feel like I've gone really fast today, but that's fine because I've got extra bonus material if I do need to use it. So the next one, I really love this problem because it represents a couple of cool things for me. First of all, the photo. This is my photo, and this is the beach on the Big Island in Hawaii. And I was there with my family, my husband, my children, their spouses, grandchildren.
And it was one of my dreams to take the whole family to Hawaii and to renew our wedding vows on a black sand beach. So we did go to this beach, and we got there right as the turtles were coming up out of the ocean and onto the beach. And I guess they just come out there to hang out, maybe lay eggs, I don't know. And so we did our wedding ceremony, or kind of just with our family, just a little wedding vows. And the other dream of mine was to use the Klingon ceremony without being attacked by the guests, but with the vows from Worf and Dax from Deep Space Nine when they got married, and used that ceremony. So I actually got to do this. The funny thing that happened is we've been married 40 years. My granddaughter, who was about 5 at the time, were walking to the cars, and she says, "Grandma, are you and Grandpa going to have kids now?" So I thought that was hilarious. And she was mad at me when I laughed at her at the time. But now that she's 8, when I told her that story, she thought it was pretty funny. So the other milestone that this represents for me is the fact that this island and gaps problem is a very common problem with data, with computer science. And it was one of the first problems that I looked at and said, how can I solve this? Will windowing functions help me? And when I started really, really getting used to using windowing functions, they helped me look at things in a set-based manner. And I started just kind of playing with things and looking for patterns. It's not something that I could just, oh yeah, I'm just going to write this. I had to look at it, think about it, look for patterns, look for ideas. And once I did, I could solve this. And that really, to me, was kind of a breakthrough. And this, back in 2012. There are probably lots of other ways to solve this problem, but I'll show you the way that I came up with. And let's pop over to the code. And this is just some, let's see, I've already created, so I've got the little table. So here's the data. And you can see that I've got consecutive numbers. And this could also be dates. It's just easier, a little less complicated to explain with numbers. If I go to past 5, notice that 6 or 7 are missing. That means this is an island here. Here's another island. Now I'm missing 12. So 13 is an island by itself. 14 is missing. 15, 16, 17 is another island. Okay. And go ahead and run that piece. Just show you the data. So that's my islands that I'm looking for. So that's the answer. I've got to work towards this answer for the islands. So what I like to do is throw a row number into something that's really tricky to solve. Row number's been around since 2005. I was using it since then, not really realizing that it was part of this group of windowing functions. And when I present on windowing functions, lots of folks have used row number. Usually, probably 50 to 75% of the room has used row number, and many of them have never really understood that as part of this larger group of windowing functions. So the first thing that I did with this is I just added a row number to try to look for a pattern. So I can see, so row number gives you a unique set of rows over a partition. I don't want to get into a lot of detail, but I used a partition back in the stock history table to keep the different ticker symbols separate. In this case, I don't have a partition. I would have it right here if I needed it. And so my partition is the entire set of results. So I've got this unique row number that just counts up. And here's my numbers that I'm working with. Notice that it's equivalent up until number 5. They're the same. When I get to my next let's see, here's my next island. When I get to my next island, all of a sudden they're not matching up. There's a difference of 2. A difference of 2 for every one of these. When I get in my next island, all of a sudden there's a difference of 3. In my next island, there's a difference of 4. So, hey, that is definitely a pattern. Every island has a different difference between the number and the row number. So my next thing to do is just go ahead and subtract so I can see that difference. So instead of looking at the row number, now I'm looking at the difference. And I can take advantage of that difference and group on that and find just the old-fashioned min and max, the stuff we've always used, to find my islands. So here's the answer. So basically, I took that query from the previous query here, threw it into a common table expression, and then in the outer query, I found the minimum and the maximum, and I grouped on that difference. I could not rate this in one query, okay? I had to separate it somehow. I could have used a temp table or a table variable. I could have used a subquery. In this case, I use a common table expression, but I had to separate that out because I had to work with that row number separately. I could not, I need that in my grouping here. I can't group on a row number, so I have to separate that out and do that earlier. But that's the answer, and it was really not that difficult. The other side of this problem is the gaps problem. So taking that same data, where are my gaps? So here's my islands, and my first gap is 6 to 7. My next gap is 12, and my next gap is 14. So I can just looking at it, I can already see a pattern. The 6, it's 5 plus 1. The 8, or the 7 is 8 minus 1. So if I take this row and add 1 to 5, I get 6. But I have to jump to this other row to do the subtraction. I could start either looking forward or looking back. Hopefully that rings the bell, lag and lead. I can use lag and lead to solve this. Use one of them, pick one. All right, so how would I do this? I took everything that I worked on before, which was just basically this, put it in a common table expression, and then in the outer query, I use lag. So for the row that I'm working on, I'm subtracting. The previous row, I'm adding. So let's see if this works. And it almost works because I really don't like this row here. I really don't like this. Otherwise, it did work. And I think this is somebody asking me about common table expressions. You can ignore that. So what I did here is I went ahead and took that final query, bumped it up to a common table expression, and then in the outer query, checked for null. So I do like common table expressions. I know some people hate them. Again, everything you do in T-SQL, use the right tool to solve the problem. In this case, each item is building on the previous step. Each step builds on the previous step, so common table expressions make sense. Okay? If I found that I was hitting a performance problem, I'd back off. I wouldn't use the common table expression. But I do like them just because they're easy to understand what's going on. So I can go ahead and just show you one more thing, because I do have another 10 minutes since I started late. Intelligent query processing. I know the previous speaker did talk about this a little bit. I'm not going to, this could be a whole hour session. But what I want to talk about is just one feature involved with this. So this is if you do a search for intelligent query processing, you'll find this graphic. You'll probably see it in every session about it. And the one I'm going to talk about is this adaptive join batch mode. This is a 2017 feature. Batch mode means that it only works if you're running it on a query that involves a column store index. So I'm hoping that in the future, Microsoft expands this to regular row mode queries. And also, it's also an enterprise edition, which keeps a lot of people from getting the benefit of it. So I'm hoping that Microsoft expands this. Every once in a while, they trickle down some, enterprise level features. So let's take a look at that right here. And my execution plan's turned on. So I am using an example from Microsoft that I've changed up a little bit, but I found that the original data, it didn't really show this. So I had to delete some rows to get this to work. And I'm also putting this into the query from Microsoft into a stored procedure. And inside the stored procedure, I'm passing in this quant variable, and then I'm filtering on it. So the other thing about intelligent query processing is you can turn the entire set on or off by changing the compatibility level. Now, there's other things you can do. You can turn off a specific feature for a database, and you can also turn off a feature for a particular query with a hint. So there's a lot of flexibility. But in this case, I'm just going to turn the feature off by setting the compatibility level back. And I'm also going to free the cache just to make sure we're showing exactly what might go on. So I'm going to call the stored procedure with a value of 360. It returns 206 rows. And when I look at the execution plan, I see that it does a clustered index scan, then it does a filter, and then a hash match. Okay, so that is the right plan for that parameter. If I run it with 78, I get back just 5 rows, and I also get back the exact same plan. I'm going to free the cache again and run these in the opposite order. And I'm sure many of you have run across this kind of problem in the past. When I look at the execution plan, it looks very, very different. And now, instead of a clustered index scan with a later filter, the predicate is pushed earlier, and I've got a clustered index seek. Also, I've got a nested loop. So what Microsoft is really doing, well, I'm not done yet. Let me run this with 360. And of course, now I'm stuck with the plan for 78. So this is just a classic example of parameter sniffing. So if I change my database compat to 2017, and I should point out that this fact order table is a column store index. All right, so I'm going to free the cache again. And this time, I am going to run against 78, and the plan looks very different. Notice that I have this path and this path. I've got 2 different paths. However, this one's got 0, and this one shows 5 rows came through. And I have this thing called an adaptive join. And if you look at the third item in this, and I forgot to turn zoom it on, you'll see that it's actual execution mode, row, actual join type, nested loop. All right, and it's an adaptive join. So what this means is this particular type of join will flip back and forth. And let me show you what happens when I run 360. Can flip back and forth depending on how many rows are going to come back in the query. So here it looks the same. However, we've got 672 rows on the scan and 0 on the seek. And if we look at this on the adaptive join, you'll see that it estimated a nested loop, but because of the number of rows that came back, it switched to a hash match. So I really, really hope Microsoft expands on this, because this is probably one of the biggest problems people have with queries is data that's, not necessarily, I don't know what the word I'm trying to say, but there's a lot of discrepancies in different parameters. Parameter sniffing is the problem. So the idea behind all of these intelligent query processing, except for one, approximate count distinct, except for that one, the idea is that you would not have to change any code to take advantage of these. And I have presented on a whole hour on this topic before. And okay, so I'll make sure that the slides get to the organizers, and there's quite a few resources for you. And I'd also like to point out that Redgate is having a free DevOps session over 2 days next month. So we'd love for you to join us if you're interested in that. Any other questions?
Yeah, I mean, Kathy, there are a couple of, if you would like to answer. The one, it's from Atul. He says, how T-SQL help in fast-paced development?
Okay, say it again a little louder.
How T-SQL help in fast-paced development?
Fast-paced development? Meaning I can write the queries faster?
Maybe, yeah.
Maybe. I think that these new functions do help you write queries faster, because some complex problems are written much easier. In many cases, the queries also run faster. Not always, but often they do.
Okay,
you gotta have the information. Anything else?
No, I think we are good. I will remove your screen share now. You can come back to StreamYard. I think you can now see us. Perfect.
Okay.
So, Kathy, that was a great session. Thank you so much for your time. We really appreciate it, and definitely, I hope this session will be beneficial to the guys who go ahead and watch it later on, and to the guys who have watched it now. Thank you so much for your time and all that you do for the community, and have a nice weekend ahead.
Okay.
Thank you.
Thanks so much.
All right. Okay. So after that, we move to our next session. That is by John. He's going to talk about improving performance with intelligent query processing. And let's go invite John to the conference. Hi, John. How are you?
Hi, Simon. How are you?
I'm doing good. Thank you so much for your time. I really appreciate it. How has life been all through this pandemic?
It's been definitely a shift and an interesting change in everyday life, right?
Mm-hmm. Yeah. We had one of your team members the other day, Monica Radban. She did talk about some topic I don't remember, but I think she did talk about performance tuning. Yeah, looks like
Yep.
everyone's talking about performance. Yeah, so it's okay, right? Performance is an important topic. So I'll go ahead and add your screen to the
Okay.
broadcast.
And
Everybody
you
can
should
see your screen.
All right, so you see
And
that slide. Okay, so you're
next
good.
45 minutes is all yours.
Awesome. Well, thank you very much for having me. I appreciate everybody attending and being here on a Saturday. I hope that everybody is staying safe in this global pandemic. My name is John Morehouse, and today we're actually going to be talking about improving performance with intelligent query processing. We actually learned about some of these features that Microsoft has released in a previous session, and Kathy had mentioned that she actually could spend an hour, and in this case, I'm going to spend 50 minutes talking about intelligent query processing. So we've heard from a couple of different speakers about this feature. So that might tell you how important it is to take a look at this so that you can improve performance of your everyday workloads. I do work for Denny Chandler Associates, and my clicker is not working because it's Saturday and it just doesn't want to work. Oh, come on. There we go. Okay, cool. I work for Denny Chandler Associates. It's a small boutique of IT professionals. My contact information there is on the slide before you. Email, LinkedIn, Twitter, my blog. Feel free to reach out to me if you have questions about the presentation today, or even if you have questions about overall SQL Server performance or health. If you're stuck on something at work, feel free to drop me a line. Everybody at Denny Chandler Associates is pretty heavily involved in the community. We like to help if we can. If it takes more than a couple hours, then we got to talk about a contract. But I speak quite a bit throughout the years, even virtually as we are today. I am a MVP data platform with Microsoft, and it's a big honor to be a part of that program. I am also heavily involved in my local user group here in Louisville, Kentucky. I will say that it took me like 18 months to figure out how to say Louisville correctly when I moved here. So just a quick blurb about Denny Chandler Associates. Like as I said before, we are a small boutique of IT professionals. We love doing SQL Server stuff. If you're stuck and looking for a project, feel free to hit us up. With that, this is kind of what we're talking about today. We've as I mentioned, several speakers have already kind of touched on these topics, but we're going to go back down into it. We're actually going to do some demos, and we're going to look at some XML execution plans. But we're going to talk about lightweight query profiling, the table variable deferred compilation, scalar UDF inlining, row mode, memory grant feedback, batch mode on row store. And I've got demos of all of that. So we can look at these features that Microsoft has released, especially starting with 2017 and whatnot, to help you improve performance of your workloads. And the important part is without changing any code. So this all started back in 2017 when Microsoft started to release some of these features, and they were known as adaptive query processing. When Microsoft released 2019, they rebranded that into intelligent query processing. So when you hear the term AQP, they're actually referring to those features that were released with SQL Server 2017. IQP is now the overall arching umbrella of those features that came out in 2017, in addition to the features that they released for SQL Server 2019. And Microsoft is pretty smart. We as data professionals have a challenge when it comes to performance tuning. We always hear about wanting to improve performance without making any code changes. So we can't change the application, we can't change certain facets of the environment, but how do we make things go faster without introducing potentially breaking changes to the application, or again, we break something else in the environment? So Microsoft knew that was a challenge, and Microsoft stepped up and said, we got this. And so they started to introduce some features into the SQL Server product to help us facilitate that end goal of improving performance. And the first part of that is they had to introduce some lightweight query profiling. Lightweight query profiling allows the engine to get better metrics on your queries to make adjustments down the road, right? So this actually provides a framework, so we can use that framework to do better performance tuning automatically using some of these features. Now, with SQL Server 2019, it's already enabled by default. But if you're on a previous version, so 2017, you actually have to opt into this lightweight query profiling by using trace flag 7412. I highly suggest if you're going to turn that on, test it, Don't go to production and put this into production and say, hey, John said to do this, because that won't work. But you can turn on Traceflag 7412 and opt in for this lightweight query profiling, and you can start to get some of these features for intelligent query processing. Now, and we've seen this a couple times already today. This is the overall arching umbrella of intelligent query performance. So we can see here on the left, and this is the graphic comes from Microsoft. I wish the colors were a little bit different. But here on the left that you see in the red blocks, those are the ones that were rebranded as from AQP to IQP when 2019 was released. So those, and we've already seen a couple of sessions about it. Kathy was talking about the batch mode, and we've seen the interleaved execution and the batch mode and the memory grant feedback. Microsoft took that and improved on it and then made it into the IQP, which now, again, is the overall arching umbrella of all those features. So if you're on 2019 or in Azure, if you're running an Azure SQL database, some of these are already in place in Azure. They don't all work with an Azure SQL database, and we'll talk about that down the road. But if you're already in Azure, you might already have these in place today. And so you can take advantage of these features pretty quickly right out of the gate. Now, one thing to note about IQP, as well as pretty much any feature for the most part moving forward, and Microsoft's pretty smart. So if you've been around, if you've been a data professional for a while, you'll remember back in the day when everything was certified on what version or edition that you were running of SQL Server. Well, starting with, I think 2016, SQL Server 2016, Microsoft started to move away from that type of validation to say, hey, we're now going to certify your application based off the compatibility level that your database is running in. So this gives better flexibility for database administrators or even data professionals, that we can control what features are enabled for our applications by changing our compatibility level of the database. And so thankfully, if I happen to be running a higher version of SQL Server, I can lower my compatibility level to meet the needs of my application if I need to. Most likely, I always want to be at the highest level of compatibility so I can get the best features and the best performance, but it's not always true. So you might incur some sort of performance regression by moving to the highest compatibility level. The important part is to remember that this is all controlled by the compatibility level. So we can shift things just by flipping a switch with the individual database, okay? When the lightweight query profiling came out, we also got some new features and some new DMVs that proved to be pretty handy. At least I think they're handy from a data professional performance issue. So the first one we're going to talk about is actually available in 2016, SQL Server 2016, Service Pack 1 or higher. We actually get a DMV now that we can actually see a query in flight and get metrics on that query. So if we have a session ID and you are able to capture that query while it's in flight, if you have long-running queries, it's easier because they're still running. If you have a lot of smaller queries, it's a little bit harder to capture because as soon as the query is finished and executed, it gets removed from that DMV and we can't find it. But we can actually use that DMV to see those in-flight queries and get real-time execution plans and other metrics of that query. Now in 2019, they also introduced one that was 2019 or higher, is a query completion. So we can actually see, before you had to go interrogate the plan cache to go get the estimated plan of the query. Now the estimated plan and the actual plan in shape form should be the same, but the runtime metrics are going to be different with the actual query plan. With this new DMV, the query plan stats DMV, as the query gets completed, it actually saves the actual execution plan, not an estimate, but the actual execution plan that we can then go interrogate and extract and do analysis on if we need to. That's pretty handy these days. So we get the actual runtime metrics of that query plan. Now, we do have to enable a database scoped configuration, and it's last query plan stats. we have to make sure that that configuration is enabled in order for that to work. But that's part of that lightweight query profiling that Microsoft introduced to help us get better performance. So that's kind of the lightweight query profiling. And so right now we're going to jump into the table variables, and we're going to go look at the table variable deferred compilation. If you've ever used table variables in your code, you probably ran into this many times. And the issue with table variables as it stands today, with no other changes, is that SQL Server doesn't know how many rows you have in that table variable. You could have 5, you could have 100,000. It doesn't really know. And so we can see here from this example from a query plan, it thinks it has 1 row. And so the query plan is almost always horrible. And you get bad performance because it doesn't have a good idea of how many rows are really in that table variable. With the table variable deferred compilation with 2019, we actually can now get a better estimate. So anything before 2019 was a 1 row fixed estimate. Too many rows was a bad execution plan. And using that, and before you always had an option between a table variable and a temp table. And my recommendation has always been, if you have anything more than 1,000 rows, throw it into a temporary table, because the query optimizer can get better metrics on that data. You can put indexes on, you can adjust statistics. There's things you can do with a table, temporary table, to get a better execution plan than you could with a table variable because of that 1 row fixed estimate problem. With table variable deferred compilation, now the compilation is actually shifted to the first execution of the statement. And what that means is that SQL Server can now get a better estimate of the data that is contained within that table variable. So with this, we can enable this. And if we have table variables throughout our code, we actually can get better execution plans. And if we get better execution plans, then our queries run faster. If our queries run faster, we sell more widgets. If we sell more widgets, my bonus gets higher. It's all about me. And so this is really important to me, especially when I go in to do performance tuning, because this is an easy fix to, hey, you got a lot of table variables, throw on deferred compilation and watch things run. Now, it's important to note that the compilation frequency remains the same. So it doesn't change that compilation frequency. All it does is it allows that compilation to be deferred slightly so that we can get a better estimate of the data that's in the table. Now, this mimics more like a temporary table. So now we have a little bit slightly different problem of where do we use table variable versus a temporary table? And my answer to that is test it. Your workload might vary. Your mileage is going to vary depending on what your workload is doing. So I would say throw it into a test environment, test your production workloads in that test environment and see how it behaves. But now we have a better option with table variables to get better performance out of it long term. So that was table variable deferred compilation. I think it's a huge win for Microsoft to throw out there. I've seen table variables used in code on a weekly, daily basis when I look at clients. So it's a really huge win. The next one that I really like is scalar UDF inlining. And this is another one of those, very much like table variables. There's a dangerous point in using a table variable in previous versions, because it's always going to get that 1 row estimate. Scalar functions has always been a huge pain point with performance with SQL Server in the way that it executes that code. It always will execute it in serial versus a parallel mode in the execution plans, which means that if you had a result set coming back from SQL Server that was 100,000 rows, or let's up that, let's say 1 million rows, it has to apply that scalar function in a serial format against every single row. And so it was always going to force a table scan or an index scan when you use that scalar function, and your performance was horrible. Code reuse is great, but if we can't change any of the application code, we have to be able to change something in SQL to improve performance. With scalar UDF inlining, we can now get a parallel execution plan and get better performance. So scalar UDFs were not previously costed during compilation. And we got a couple of different ways to actually enable this. It is a database scope configuration. So we can adjust it there, but we can also adjust it, and that first one is how we do it from a database scoped configuration. So we can turn it on and off there. We can also use a hint, so we can disable that scalar functioning if we want to using a hint, or we actually can have a inline command to turn it on or off. And we can also, again, the database scope configuration. Now, with some things that Microsoft releases to help us be better data stewards and improve performance, sometimes there's always gotchas. And the scalar UDF inlining is one of those that comes with a bunch of gotchas. And this is one that is not available for Azure SQL Database. It is not there yet. I expect it to be there. I have no knowledge of that whatsoever. But I would think that Microsoft will eventually get that into Azure SQL Database. But we have a whole slew of requirements before SQL Server will actually inline that function to give us better performance. So there are limitations, and those limitations are kind of long, as you can see as the list moves on. If your scalar function falls into any of those requirements, then SQL Server is not going to inline that function, and you won't get the performance benefit from that capability. Now, if your function does not fall into that list and can be inlined, we can actually see when that function gets inline or is inlineable with the sys.sql_modules system view. So we can actually look at that function and see if that function can be inlined or not to help us facilitate better performance. So if you happen to be in 2019 and have it enabled, go take a look and see if that function or those functions are inlineable. You might be seeing a vast improvement in SQL Server performance because SQL Server can now inline that function and get a parallel execution plan and not stick with a serial and not get a table scan. All right. So we talked about table variable deferred compilation. We talked about scalar functions inline. I've got demos of all this. So when we get to the demo piece, the next one we're gonna touch on really quick, and I feel like I'm moving really fast, is memory grant feedback. This is another one that I really like that SQL Server has put into place to help us get better performance and better metrics. It was added in SQL Server 2017, but it was only added for batch mode. And in 2017, batch mode was really only for column store indexes. So, but it doesn't actually change the execution, but it changes the context of the query. So if you've been doing performance tuning, you've probably at some point in time seen things that are like tempDB spills. And so what that really means is that if there's not enough memory granted to the operator of that query, particular operators in the query, the operator can say, hey, I don't have enough memory, so I'm actually going to go use tempDB to facilitate that. And that's a spill. That means that the query has actually spilled over to tempDB to facilitate processing the data within tempDB in order to satisfy the query requirements. Memory grant feedback allows the engine to adjust things based off what happens. So if we get a spill to tempDB, and the query needs more memory, the memory grant feedback on subsequent executions can actually allow the engine to say, hey, the first time we ran this, we spilled the tempDB. I didn't have enough memory. I only got 10 megs of memory, but I needed a gig. The engine can now adjust on subsequent executions and say, hey, first times you didn't have enough memory. This time, we're actually going to give you more memory based off what the metric said from the previous execution. So SQL Server can actually adjust the memory grant for the query and the operators to facilitate better execution so that it doesn't spill to tempDB. If a query spills to tempDB, you can get performance issues. So this is one way that the intelligent query processing with the memory grant feedback, we can get better performance because the query can actually adjust as needed. So I can give it more memory, but it can also decrease the memory, because if I give a query or an operator too much memory, then I'm potentially starving memory for other queries. other queries might need more memory because of the way that the query is running, where the operators it's using. So the memory grant feedback can actually dynamically adjust each query based off its true needs. Because we have that information, those metrics from the lightweight query profiling that SQL Server now uses, we can actually adjust that memory up and down depending on what we're actually doing. So this is a really cool way that we can dynamically adjust the performance and not spill to TempDB and or starve other queries just by enabling the memory grant feedback with the database scoped configuration in our code. Again, these are things that we can turn on and off without changing a single lick of application code, which shouldn't break a thing. Test everything, always test, but we should be able to turn this stuff on pretty easily. So that was memory grant feedback. All right, so the next one I really like is batch mode on row store. So when column store indexes came out and whatnot, they actually introduced a new way to process data out of those column store indexes, and it was in a batch mode. But if you don't have column store indexes, doing a batch mode is actually better performance because it would process rows at about 900 rows at a time. It really was introduced with SQL Server 2012 and column store indexes, as I mentioned. But because we can process rows at about 900 at a time, SQL Server can process larger sets of data better. It is great for analytical queries, and that's one of the benefits of using column store indexes if you have a large data set. But what if I have a large data set that's not analytical, it's online transactional processing, and so, but I still want to take advantage of that batch mode? I can't do it unless I get to SQL 2019 and enable this database scope configuration, this batch mode on row store. So that batch mode also reduces CPU consumption. So not only do I get better performance, I get lower CPU. So again, it's great for analytical queries, but I can't have one or the other. So I'm either going to be in a batch mode or a row mode, but I can't be both. But with batch mode on row store, now that I have that online transactional processing workload, maybe I've got 100 million rows in an OLTP table, turning this on, I can now get better performance with a batch mode on a row store and not a batch mode like on a column store index. So I can enable this, but there can only be one. So it's one or the other. So these are 4 of the intelligent query processing things that I think are a really great addition to SQL Server, especially SQL Server 2019. So now we're going to jump into demos. I feel like I'm moving really fast. I've got about 20 minutes left, 25 minutes left. Are there any questions, Simon, before I jump into the demo?
We are good.
I'm going to shift things around while
You can take your time. It's okay. You got to breathe now. You can take your time.
Let me see. Can I switch my screen?
Yeah, you can. There are no questions. It's okay.
Let's see. How do I switch my screen? There we go. Okay. Yep. Hang on. Ta-da.
Okay, I did back.
Perfect. Yay. All right. Hopefully everybody can see that. This is my management studio. And I apologize. I feel like I am flying right along. So this is the first one we're going to look at, and we can see that I am, this is a local SQL Server 2019 instance on my work laptop. It is running SQL Server 2019. Don't mind the whole slew of databases I have. I tend to really try to break my local instance quite a bit. But these are just examples of, if I use AdventureWorks 2017, we can actually see that lightweight query profiling is a database scoped configuration. I do have last query plan stats enabled here, so I could see it. Now, I don't have any active workloads on this particular database, so I don't see anything in this DMV at this point in time. I can go back though, because remember with the lightweight query profiling, we also got the ability to see the query plan stats, so I can actually go back and see the actual query plans, not the estimate, but the actual query plans that were landed after the query finished. Now, these are all system ones. Maybe if I went down through here, I could find something that was more application-based. Let's see. Looks like these are all system ones, no big deal. just an example that I can actually go get the actual query plan, not the estimate. So that's just an example of lightweight query profiling and some of the cool DMVs you get right out of the box. So let's take a look at the first thing we talked about, which was the table variable deferred compilation. In this case, I'm actually going to use, and I always say it backwards because I want to say worldwide importers, but it's wide world importers. But we're going to use the wide world importers sample database in order to mess around with some of this stuff. I'm going to check to see what's enabled. We can see that I've got the deferred compilation table variable enabled. I do not have the last query plan stats enabled. In this case, I'm okay with that. But I do have the lightweight query profiling. I need that lightweight query profiling enabled to take advantage of the features that I already previously talked about in the slides. So I'm going to go ahead and turn on the last query. Oh, I'm going to turn that on. And then I'm also going to set my compatibility level back down to 2014. 130 is 2014, 140 is 2016, 150 is 2019. So remember that these features can be turned on and off based off what compatibility level you have your database set to. So I'm going to create a procedure in the database. It's going to do some work. And again, it's going to use a table variable to facilitate that. Make sure that's in there. Cool. I'm going to pull some data into cache just because. And then I'm going to run that store procedure that is going to use that table variable. And remember that I'm in 2014 compatibility, so the query optimizer thinks it's on for all intents and purposes, it's on a 2014 box and it's going to behave like that. And I'm going to run that. Now, if we look at the execution plan, we can see here that I have the table variable. But if we look, we can see here that as we expected, because I'm in the 2014 compatibility, I'm getting SQL Server only thinks that there's one row, but in reality, there's 228,000. That's a pretty vast difference in terms of how many rows are actually physically within that table variable. I want better performance. And so if I go back to my query and alter the compatibility level and bump it up to 150, which is 2019. And remember, I've got the table variable deferred compilation database scope configuration enabled, and rerun this. I get the same number. I'm going to look at the execution plan. We can see if we hover over my table variable now, move over here, I now have an estimate of 228,000 rows, and it matches my my actual rows that it read out of that table variable. This allows the query optimizer to get a better execution plan. You'll also notice that the execution plan shape actually changed based off using that table variable deferred compilation setting. So I actually get a physically different execution plan. So really, as you can see here, really easy to enable, doesn't take much, but we can see a vast difference in terms of execution plans. And you can see where the performance would be better by turning on the table variable deferred compilation. We'll clean some of these up. So the next one we talked about was the inline scalar function. So let's go ahead and take a look at this. We're going to use, again, the wide world importers. I'm going to set the database back down to tables or 2017 compatibility level. I'm going to use the database. And whoops, I would say don't type in a demo. So here we can see that the database, now everything's turned on. In the previous demo, I turned on the last query plan stats. This one already has the scalar UDF inlining turned on, and I've got the lightweight query profiling enabled as well. Here, I'm going to create a function in the database, if it's not already there, that's going to basically just count some quantities out of the sales order lines table to do our function. Now, so I've got this noted, and I keep grabbing the wrong thing. I have this noted that it's going to take 3.5 minutes to run. Looks like we have about 3.5 minutes, but well, I'm not going to let it run. But if I start this, we can see that we get results back. And actually, I need to turn on my actual execution plan. And that's actually not going to finish. So we're going to do this. We're actually going to use that new DMV in order, because this query is in flight, I can actually come over to a new session. See if I can find it. So this is the actual execution plan of the query that is currently in flight. So I can actually see what this is doing. Now we can see this plan looks pretty simple, pretty straightforward. It's not overly complex, but we can see that it hasn't actually expanded that function to be inline. And so we can see that we're going to get a clustered index scan out of this query. So if I come back over to my demo and cancel that, we're going to cancel that. So I'm going to go ahead and up this to 150. So again, I'm going to put it back into SQL Server 2019 compatibility and run it again. Can I move that? Oh, cool. I can move that. Now we can see that the query actually completed. So it's not running anymore. So I can't grab it out of that in-flight DMV. Now I can actually get the execution plan. Now in this case, I had enabled show me the actual execution plan, but I could go get it from my new DMV if I wanted to. We'll notice that the plan shape has really changed. We can actually see now that we actually get it expanded out, and it actually puts that function in line with your code. So we get a better and a different plan shape out of SQL Server. So this will perform better if you are using scalar functions. This is one of those features with SQL Server that really helps us improve application performance, because we all like to do code reuse. And so having code reuse in a scalar function, we now have a way to improve that performance with the newer versions of SQL Server without making a single change to an application somewhere. So this is one of those ones that I really like from a DBA perspective, because battling scalar functions was always one of my worst nemesis, because there's not much you can do other than completely rewriting that function and injecting it manually into your code in terms of stored procedures or SQL queries in order to get things resolved. This makes my life easier as a data professional and doing performance tuning. This definitely makes my life easier in terms of getting better performance by a simple switch of the button. So I really like this one. Okay, so that was scalar function inline. So pretty easy to enable, pretty easy to see where this could be applicable in your workloads. And so let's go on to memory grant feedback. This is another one that I really like. And again, I got about 15 minutes left. Again, I feel like I'm just screaming along. So let's see. We're going to use wide world importers still. I'm going to go ahead and clear the cache out of the database scope configuration. I'm going to set the compatibility back down to SQL Server 2016. So I hope you see how the database compatibility level really helps to adjust what you can or cannot do with your databases moving forward. So if we look at the available database scope configurations, you'll see that there are two. One is batch mode and one is row mode. Remember that the batch mode really pertains to like the column store indexes. So that's been there for at least 2017. So the row mode is the new one that we really like. So if we do a query on wide world importers, I don't have my query plan enabled. Of course not. Oh, I do. I thought I didn't. So we're going to run. This should not take long, I don't believe. It comes back. So in the lower compatibility levels, and we've probably all seen this warning, we can see that yellow bang warning that a SQL Server is telling you, hey, there's a problem with this query. You might want to take a look at it. And so if we hover over that, one of the things that we'll notice is down here in the bottom. SQL Server is telling us, and remember, I'm in the 2016 compatibility. SQL Server is telling us, hey, I gave you way too much memory for this particular query. I initially gave you 731 megs, but you only used 5.4 megs of that 731. That's a pretty vast difference in terms of memory utilization. And think about, now this is my laptop, right? I don't have any other workloads going. If you have a very busy system, that excess, 726 megs could be very much utilized in a different query elsewhere and not starving a query somewhere else in the system. Okay, so if we change the compatibility level up to SQL Server 2019 150, and we talk about, and then go look at the execution plan again. Oh, whoops, the other thing I wanted to show, actually, let's go back here. Actually, we'll just move on. I did not show what I wanted to, but we'll come back here. So I've bumped it up to 150, so I'm in 2019. I've got that memory grant feedback enabled. We look at the execution plan. We still see this. We still see this memory grant in the warning down here. We can see that the memory grant changed slightly. I'm still using only 5.4 megs, but they gave me 819. Thankfully, I've got 32 gigs of memory on this machine. But if we look at the execution plan XML and come in here, one thing I want you to look at is this memory grant info line right here. So we will look, if in the previous XML, this wouldn't be here. But what I want you to look at is this feature, is memory grant feedback adjusted? So SQL Server knows that that memory grant feedback option is enabled and is telling us in the XML, hey, you've got it enabled, but you have to run the query first to level set that expectation in terms of what memory I am using. So it's the XML from the query plan is actually telling us, no, it's the first time you've executed this since enabling this feature, so I need to do metrics first. I'm not going to adjust a thing until subsequent runs of this particular query. So if I come back to the query, I'll back out of this and run this again and let it finish. Couple things here. We'll notice that I don't have a warning anymore. There's no yellow warning sign on this select operator right now. So if I come and look at the execution plan XML, let's go take a look. So again, I'm going to look at this memory grant info line in the XML. The XML will actually tell you a ton of information. If you haven't looked at the query plan XML, there's a ton of information in there. We look at that is memory grant feedback adjusted line. SQL Server then said, hey, I gave you way too much memory that first time. I'm going to adjust my memory grant for your query, and I'm going to dynamically adjust it down and only give you what you need. So we can actually come back out and look at the execution plan. Where'd it go? I gotta go find it right here. I can't see, the memory grant is much less. If we actually look at the mouse over, we can see that instead of 730 megs or 800 megs of memory, SQL Server actually says, hey, you only need 5.5. I'm going to give you 8.5 megs of memory just to be safe. But 8.5 is significantly less than the 800 megs of memory it gave me the first time after turning on this feature. So I get better performance. I don't spill to temp DB with this. And I'm not starving other queries elsewhere on the system by having this enabled. And again, think about it from a global perspective. If I have an application that is has queries that are doing excessive memory grants and lots of spills to TempDB, this is an easy fix to get better performance right out of the gate with a couple simple changes. Again, test everything. Your mileage may vary, but test everything. You can see where performance can definitely improve. Okay, I got about 9 minutes left. So the last one, batch mode. And again, the batch mode on RowStore allows us to process, especially online transactional processing data, kind of like it's analytical. In this case, I'm actually going to switch over and I'm going to use AdventureWorks data warehousing and use that database instead of wide world importers. I am going to set it down to 160, or I'm sorry, 2016, SQL Server 2016. I'm going to check to see if I have batch mode on row store enabled. I do, so it is enabled, so I can utilize this feature to get better performance. I'm going to take a look at a query, and this query is actually going to touch a column store index, so we can actually see here if we hover over. So this is my fact reseller sales XL column store, clustered column store index. If we hover over it, we can actually see that my execution mode is batch mode. So this means that I am processing rows, about 900 rows at a time, give or take. It's approximate, but I'm executing that in a batch mode process, and I want to apply that batch mode into a row store. So it's pretty easy to enable. And I know Tracy's coming up behind me, so I want to get this done. I think I missed a 150. Oh, whoops, I did. Huh. That's what I was doing. Huh. Put that back on 140. If I execute that, just real quick, I want to try to get out of Tracy's way. Let's see if this comes back. If I look at the execution plan on this row store, we can see that I'm actually in a row mode, right? I'm not in a batch mode. If I enable 150, I'll just run this one to speed things up. So I'm going to run this. This is against a row store table. I don't have a column store index on it, but I can look at the query plan. We can see that my plan shape's a little bit different. If I hover over it, we see that we actually get a batch execution mode. So now we're using the batch mode on a row store. And so we get better performance because we're processing data in a faster set, just like we would with a column store index. So we get better performance long-term by a simple change. So those are my demos. Let's see if I can. And that's not going to work. Oh, my screens are all jacked. Sweet. Let's see if I can do this. Tracy, I'm so sorry. That's still not going to work. Well, so I will just talk through it. We can just do this because my screens just don't want to work right now. So there's with these new features with intelligent query processing, some of them are not enabled for all versions of SQL Server. So the batch mode on row store and the row mode memory grant feedback is only available for enterprise. The other two you get with standard. So if you're running standard mode, you can take advantage of those. If you're running enterprise, you can use all of them. And again, the inline scalar UDF inlining isn't available for Azure SQL Database at this moment. Again, I expect somewhere down the road it'll come to play. Quick summary. This is a really easy way to get performance gains out of your SQL Server environment. You get better flexibility, and just remember that you have to be at compatibility level 150 in order to take advantage of it. So definitely test your applications with the higher compatibility levels, but easy way to get better performance, pretty straight out of the box and easy. So, and it's a great way to get rid of anti-patterns. If you've got bad code, turn some of this stuff on, you can get rid of anti-patterns. And with that, I'm done. Thank you very much. If you got questions, feel free to hit me up on email, social media, follow me on Twitter, read my blog, but I'll be around if you got questions. And I don't know if Simon's got any questions or if we want to jump to Tracy.
John, if you can read the private chat, Tracy says she'll get revenge on you.
I know Tracy, and I suspect that she'll get revenge on me somehow. I'm so sorry, Tracy.
That was a great session, John. I know we gave you a session almost like 10 minutes late, but I could see you speaking so fast. That was a really great session. I think you got a lot of content over there. Definitely a lot to learn. So Thank you so much, John, and we will see you some other time. Thank you so much for all that you do for the community.
Yeah, thanks for having me. Appreciate it.
All right, John. Bye. Take care. Have a nice weekend.
Bye.
All right. So with that, we move to our final session of the first half. We still have almost like half of the conference left, and for this session, we have Tracy, who's going to talk about SQL Server configuration with DBA tools and DBA checks. So let's go and invite Tracy. Hi, Tracy. Welcome to the SQL Server Conference.
Wow, where'd you come up with all those pictures?
I don't know. My team did it.
I didn't even know some of those existed.
Yeah. I could see it. I think it was the longest one that we made. There were like 8 to 9 pictures.
Yeah, but I think y'all asked me for pictures. I was like, I think I have one. But,
Yeah,
so
I think they did a good job. They found from tagging and all. So thank you so much, Tracy, for your time. We really appreciate it. I know it's weekend, so taking time on weekend is really tough. So we really appreciate it. And I also know we are already 7 minutes in your session. So I already see your screen. Once you move to your slides and add it to the stream. And there we have a guest in the background.
yes, we have the cat. She's always going to come in and
why do all SQL people have this cats? I don't know.
if I can keep her off the desktop, that will be nice. So I assume you can see my full screen on the slide deck.
Yeah. Oh my goodness. Right. Okay. There's some captions coming in. That's so cool.
So we're ready to go then. So.
Yeah. All right. There you go.
All right. Good afternoon. We're going to be talking about SQL Server configuration with DBA tools, DBA checks. I'm Tracy Baziano. A little bit about myself. I work at DocuSign. I have over 20 years experience with SQL Server. There goes my contact information. The easiest way to find me is just go to databasesuperhero.com. My email address is available there along with my Twitter, LinkedIn, and all the other various ways you can contact me. I have a whole lot of icons on here. Some of them need to be removed because past disappeared on us. So I'll talk about my volunteer work, which I normally do in the top right-hand corner. I'm a guardian ad litem in the state of North Carolina, which means I advocate for foster children in the court system. So I've done that for 18 years and for 56 kids at this point. And down in the bottom right-hand corner, I am on a mental health council for disability rights in North Carolina, trying to set the course for what type of things we advocate for in the state of North Carolina. So, and I'm part of speakingmentors.com so that we can try to get more speakers into the community. So those are the things that I like to broadcast. All the rest is just fluff. So we'll talk about installing DBA tools and DBA checks. Just so you know, it runs on Pester, but Pester 5 breaks DBA checks, so don't install it by using the defaults. The first thing you're going to want to do is install Pester with the correct version. So this is the correct syntax for that so that you don't end up with Pester 5. If you go to install the module for DBA checks, you will automatically end up with Pester 5, and then you will be in the SQL community Slack asking what happened. Then you can install the module for DBA checks, which will automatically download DBA tools because it's dependent on it. And then you'll be off and running and ready to use it. So that's pretty simple. So we'll talk about what DBA tools and DBA checks are. DBA tools is an open source PowerShell module started by SQL community over in Europe, but there's like over 100 contributors to it. It has like over 500 commandlets at this point. And it's made to do just about everything you can do in script and XSMS. Of course, there's some things that still haven't been added to it yet. And as you come up with those, you can go to GitHub and put in issues or contribute to it yourself so that we can eventually have everything scripted out and have PowerShell do everything for us. To illustrate some of the commands that there are, you can do a git command on the module, and this is the full command here, and where you can get a list of the commands. And as you can see, there's a bunch of different commands for like adding things to an AG, backing up things, clearing out your latch statistics, your wait statistics, copying a number of things between servers. Just you got a slew of things that you can actually do here. So it's a very worthwhile project to get involved with and use because you can automate a lot of your processes using it. So what does this have to do with DBA checks? Well, DBA checks is basically the same thing as far as it's developed by the SQL community, but this actually checks your configuration on your SQL Server for your default configuration, which you can customize with some parameters and make sure that all your servers across your whole environment are configured the correct way, and you can run audits on it and make sure things are running correctly and nobody's changed like your max memory to something you don't want or your max stop. You never know, you might have some system out there where somebody accidentally ended up as a sysadmin and changed things on you, or it's just not following a correct policy. I've programmed the CIS security compliance stuff into DBA checks. So if you have to be compliant on security for that, that's available for there too. So you can make sure you're compliant on there. And we're actually working on a module for the government in America for DISA so that we can check those configurations as well. But it provides output to a Power BI by default, which is the easiest way to visualize it. But you can also get it to a table or to a JSON file, so you can get to a table so you can query it easier, or to a JSON file so you can import it somewhere else that you find beneficial. And it all uses DBA tools functions to retrieve values to be tested behind the scenes if there is one available. If not, it's got T-SQL probably encoded in it, or it's using some sort of PowerShell that if it's a Windows related thing that it needs to check. And as I mentioned before, it uses the testing framework for Pester so that it can actually do the testing part of it. And it's a nice, easy framework to learn. So if you're looking for a project to contribute to, DBA tools and DBA checks is a good one to consider contributing to. So DBA checks itself has very few commands because it's just checking things for you. Everything's behind the scenes, but they're very customizable. So this is all it has. So we're going to go over the invoke DBC check and a few on setting the DBC config values so that we can actually customize our environment for us. And as you can see, when we do a get DBC check, these are all the different things it can actually check for and then some. So there's a lot of SQL agent checks, database instance checks. So we're checking on the agent to make sure your database mail is enabled, or that your service accounts is enabled. You got a database operator, whether you've got failed job things running, whether it's got a valid job owner, whether jobs have failed, whether jobs have been running long, things like that. And there's a slew of tests that can run on here, and it's just nice to have. Like, we even put suspect pages in here, so now you can see if a page ever became corrupt on your system and you just didn't know about it. And so if you run these things, you can keep up to date on your environment and know what's going on, as well as making sure the config is correct. This is a command to run to pass it all through to Power BI. And then once you do that, you just hit refresh, because by default it's showing data that's stored in Power BI, because that's what Power BI does. And then you'll have your report customized to what you have sent in. So this is what the default report looked like when I first started this presentation. I have it up on my VM right now to see where we're at. It has 126 failed things. We're going to see how many failed things we have now. And we're going to try to fix as many of them we can and in the amount of time we have for this presentation. So now we're on to demos for the rest of the presentation. So we're down to 125 failed things, 126, so that's good. As you can see, our top one is all about agent alerts. If you click on it, it'll actually narrow down the results down here at the bottom and tell you which things it's missing. So let's mention agent alerts for the severities. And there'll be several other things like database mail in there and things like that that we need to add on to agent alerts that are notified down towards the bottom and not showing up here at the top. So we're going to go in and do some of these basic things after I show you a couple of basic things about using PowerShell. So I've already ran my update modules on here. So we got the newest and greatest version. This is one way to actually find commands. This is a module built into DBA Tools, so you can actually go in and find one of their commands because they have so many of them. It can be kind of hard to find. Where'd my grid go? So you can actually come in here, and then you can use the criteria on the grid view and look for something that has a keyword in it and try to find a command that does something. And as you can see, there's a number of commands that you can actually use. Oh, great. My mouse is disappearing. Okay, it's back. Then you can do the same thing and tag it for agent. So if they have a tag for agent, it'll come up with the agent. Due to time, we will skip running that. But we've got our checks also for DBA checks. As you can see, there's a number of these that run on the system. And again, you can go in here and search by adding criteria and looking for keywords. So that gives you an idea of how to go and find things. Then you've got basic commands in PowerShell where if you need to look up what a command actually does, you can just do a get help. Some of this stuff you may know just the basics of, but I wanted to cover it because it's kind of gets you started and tells you how to find examples of how things going. So if you don't know how to use something in PowerShell, you can use a get help and it give you the basics of how to use this and maybe some information on where to go to examples on how to do things as well and the descriptions. And then you can get more detailed, like if you only want to see examples or you want to get a detailed description or you want to see the full help that they put in there, you can do that as well. And you can tell it to pull from online just in case you don't have the newest documentation on your system. So that's the basics of how to go about PowerShell and use DBA tools and DBA checks to kind of check things out before you actually get started. So now let's go in and try to fix up our SQL agent alerts. So first I'm going to clear the host so that the bottom part's kind of empty for us. I'm going to set our instance name to our instance name, which is just DBA Tools 2. The first thing we need to do is set up a mail account. So I've set a number of variables here that are going to be our defaults. Nothing major going on here. Then I'm going to set our config where these values up here are going to be our defaults that it checks against. So if you have 100 instances, you're going to always want your DB mail account to be named DB mail. You're always going to want your email address to be this and so forth. And then we're actually going to take a look and see that those are set. As you can see, we've got your mail right here and DB mail above it, and our operator names and stuff is going to be set later. So then we're going to pull in a connection to the server because we're going to need this to do some SMO because not everything's available in DBA tools for some of this. So but the first thing we're going to want to do is enable our database mail if it's disabled. So we'll go ahead and do that. And we can see here that the previous value was 0 and the new value is 1. So it was indeed disabled by default. Then we're going to actually add a database mail account. And we know it doesn't have a database mail account because I just installed SQL this morning. Then we can see that it created us a database mail account on this SQL Server. Then we actually need a database mail profile if there's a new one, and we need to set the mail profile to the default on the system. So this is the part where I had to use a little bit of SMO to get everything set correctly. But as you can tell, DBA Tools went in and it created everything for you. Then we're going to set as an operator. This is actually a new commandlet that I wrote because of this presentation so that we could actually create an operator. So now we got an operator created that's going to get paged, every day and get alerted on their emails and things like that. Then we're actually going to set it to be a fail-safe operator so that if we don't have another operator, it will be the one that gets notified. Now, so far, they've got a get DBA agent alert and a copy. I'm going to work on one where you can add a new DBA agent alert. So we're going to actually use SMO to add alerts at this point. But this 16 ... through 25 will tell it to add all the severity 16 through 25. And we're just going to name them severity alert 16 through 25 and add them. And then we're going to add these severity numbers here for corruption type errors. And it's just a for each loop on both of those. Then we shall run our Power BI report and see if we get our numbers down from what was failing. While that Power BI report comes up, we'll look at SQL Agent and see that we do indeed have alerts. As you can tell, we have alerts now. We do have an operator. So those type things worked for us. And we'll be able to tell by our Power BI report too once I was supposed to close that so it would actually work. Good thing it hasn't gotten to the part where it opens it. This is normally the part where I take questions, but I don't know if this is interactive or not. I shall look in the comments and see if there's anything in there. And there is not. So if there's any questions, feel free to throw it in the comments at any time, and I'll be checking them every time I run the Power BI report. This takes a minute or two to run so that we can actually see results. But it's good to check our results as we go along. Our next steps are going to be we're going to work on all the hologram scripts and installing those because those are going to show up as our next biggest thing. And we'll go through that in a minute after we look at our Power BI report. Oops, too many clicks. And you can run this on more than one server at a time. You can actually run it with different names like prod and test so that you can actually separate out your different environments so that you can see differences because sometimes test isn't configured the same as prod and so forth like that. So there's a number of things that you can do to customize this. I'm just doing the basics of running it against one server to get everybody familiar with it. Working on it. Yay. Come on, Power BI. You can do it. Okay, we're down to 86 failed from, I think it was 126. So we're doing better. So now we're going to look at fixing up all the hologram stuff because that's like 4 for each one of these that's failing. So let's try to get each one of those fixed up now. Remember to close Power BI this time. Clear my host. I'm going to set a couple of things, just the instance name, where I want my backup to go, and how often I want my backups to be cleaned up so I can feed it into each one of these jobs. And then I'm going to email what my email operator is going to be because we set that up in the first page. Now, one thing you can do, which is kind of neat, is you can install the solution right off the internet. With the appropriate variables that you need, log in a table, install jobs, get everything, and we're going to place the existing one. So within seconds, you actually have the newest, greatest version of all hologram scripts installed. So now we're going to take a look at these jobs right here. Our system backups and our user backups are going to run Sunday at midnight, and that's going to be the name of our schedule. And for each one of those, we're just going to add a schedule to it. That tells it to run weekly. We're going to do the same thing on our diff, tell it to run all the other days at midnight. We have to put 2 different schedules on here because you're going to own because of Saturday. But now those jobs are scheduled to run. Now we want our logs to run, I say every 15 minutes. So we got our frequency set to daily, every day, minutes 15. Then we're going to set our integrity checks to run at 2 a.m. on Saturday. Sounds like a good time, right? Nobody's busy at that time. If you can afford to run integrity checks live on your system. And the same with the optimized job for our indexes. 10 p.m. on Saturday seemed like a good time. And then all these miscellaneous jobs for cleanups and things like that, I just set all those to run every day at midnight because it'll keep things clean. Now for each one of these jobs in here, we do not have an operator for those yet because you can't define those when you install it. So we're going to get back each agent job that does not have an operator, and then we're going to set the operator for it to, on failure, to email us. That way we can have alerts. So I am going to set my recovery mode on my MSDB to full so that we can simulate having some backups later. And because we do have a check for backups in here, I'm going to go ahead and run my full backups and and we have integrity checks too. I'm going to go ahead and start those jobs up so that those will disappear off our reports as well, because those should only take a few seconds to run. And we'll give that a few seconds to run, and I will go check for questions while I go kick off the report again. Back to here. And no questions, that's okay. So you can see how easy it is to install all the Halogram scripts. They have a number of other things that you can actually install very easily that we'll go over in the next slide deck, like Brent Ozar's Blitz scripts, the SP who is active is installed right off the internet. So there's things you can do to automate these and keep them up to date, because I know Brent changes his nearly monthly. So you can always have the newest and greatest versions set up, and all is you probably want to check for features before you upgrade it, but the others you probably just would automatically update. Come on, Power BI, you can do it. Power BI is so slow sometimes.
Some background music for this.
Huh?
We need some background music.
I know. This is usually when I get questions, so it's like, nobody's asking questions. Good news is I only have to load it one more time after this. And I'm talking a little bit fast, so we'll get back on schedule so everybody can eat lunch. And because I'm not taking questions, getting questions, it's not taking as long either. So hit refresh. So while that's running, we'll go ahead and go check out what my next set of code is going to be. Oh, we won't. Yes, we will. Power BI is trying to take over. Look at it. Shrunk my screen. Hate when things like this happen. Can't run 2 things at once with Power BI.
You can take
Okay.
a minute to learn. Okay. So
Huh?
Okay, so all right, it's good.
Yeah. I'll just be patient. I just don't like the silence. Say silence.
Paul has a question. Do you want to take that?
Sure. Let me go back over here to look. Yes, I do keep them in master. I prefer them in master. The only time I move things out of master is if I was capturing SP who is active to a table or Brent's first responder stuff to a table, I would put that in a DBA database. All the scripts I'm not worried about. I know he has the command log table, but he also has the thing that automatically cleans it up. So I put the others in a DBA table just in case I don't have something to automatically clean them up and to make them more efficient. So if I have all 3 of those installed and for some reason I'm keeping one to a table, then I would put all of those in a DBA table. Otherwise, if you're not keeping anything to a table, I would just put them in master. So can I run my checks in SQL Server Agent? Yes, you can. There's a blog post out there somewhere that shows you how to run PowerShell in SQL Agent, and then you can write it to a table or to a JSON and have something to automatically swoop up and get the results. So now we're down to 29 failed tasks. We're doing really good. We're not going to fix them all, by the way, just in case anybody thought we were. But we've pretty much got this pretty much cleaned up at this point. We've got a few other things we want to run, like SPU is active. We need to rename SA, and a few of our SP configure things need to be turned on. Query store needs to be enabled on something. We want to install a CU on our system so we can do that, and a few other things. We need our DAC turned on. That's important, our backup compression. So we're going to go in and do some of the miscellaneous stuff now. Hence my name on my miscellaneous file. So I always like to have optimized for ad hoc workloads turned on since like 2008. I love to have my DAC turned on since it was invented in 2005. I don't remember when backup compression was invented, but I like it. And as you've seen, it wanted our remote access turned off. So we will configure those real quick. And you can tell if we scroll back up that it changed values for us. And this one requires a restart of SQL Server for you to be able to see. So anytime you use a command like the set DBA SP configure, it will warn you if you need to restart SQL Server because your config value needs to restart it. We won't be doing that because we don't really want to at this point. We're kind of using it. So when you install SPU is active as long and all the hologram script, as the question before was, you can actually tell it what database to install it in. This one requires it, so I put it on there. So now I've got SPU is active installed. And despite some errors you might see when installing the first responders kit, it does actually install correctly. And there's another project called SQL Watch that's made for monitoring your servers that you can actually install using this as well. And you can actually run Glenn Allen Berry's diagnostic queries as well and get the output saved somewhere. So there's a number of things you can do with DBA tools to do these because these are all DBA tools commands. So we're going to turn our query store on. As you've seen, we had an alert for that. And the only one that we can actually turn it on is the MSDB because we don't have no user databases. So we've got that turned on. And that's the only system database you can actually turn it on in. And you actually can't see any data without going to the catalog views because there's no GUI for it. Then we're going to actually rename our SA account. Go back, change what? Did not like that. We'll figure that out someday and figure out why it's not working. Let's make a note of that. I know it's worked before, so we'll have to see if there's some override that needs to be stuck in there. Let's try force. Sometimes they have those commands that need to be done. Force is not a parameter. Well, I'll have to take a look at that, and I'll fix that when I upload these scripts to my website or to C-Sharp's website if they have us upload them. There's a couple of trace flags that were popping up too that you need to enable. One is the backup thing that keeps it from going in your error logs, because if you're backing up tons of databases every 15 minutes with your T-logs, you're just filling it up. The other thing we're going to tell it to do is to not expect 117, because this is turned on by default in 2017, and we're setting these as config values at this point so that DB checks knows to check it. And we're going to tell it to skip temp DB 1118, because that's again turned on default by 2019. So then we can tell it to actually enable the trace flag 2226, because that's the one that we actually told it to expect. And because we're using query store, there are 2 trace flags that you normally would want to turn on in a different environment, but those are actually defaults in 2019 as well, so we don't have to worry about those. Now, if you for some reason wanted to check for orphan files, there is a check for that. You could check for those and then go through them and delete them. That check was not popping up, so we'll skip that one. And we'll go ahead and run the Power BI report again after we close it. So that's most of the things that are going to be fixed. Now, one thing to note is I told you I wrote some CIS security scripts for just checking security. If you just want to run something that's in a particular category, you can just put the tag here. Like you could run all the agent checks by itself and it'll output it to a file. So if you wanted to be CIS compliant, you could just run the CIS report separately. Some other commands that you might find useful while that's running is to set your power plan on your system. I know that's an old thing, but some systems still don't have them set correctly. Another thing is your cost threshold for parallelism. As I mentioned, Glenal and Berry scripts can be ran to a temp folder and you have all your data outputted to a CSV. You can actually run database compression using DBA tools and output what it does. And based on if it saves you 25%, it'll compress it. And then we're actually going to pull this trick and update our SQL Server instance once it finishes checking everything to the new cumulative update, which I did not download the new security one, but I do have the last CU before the security update. So I'm going to let that run so you can see we'll get a newer version of SQL Server and we won't be on RTM, which is where we're at right now. And it's asking us to update it to CU8. We say yes. Because that's what it's read out in my temp folder. And it's preparing to install it. So that's kind of neat that it can do that automatically for you. And you can do this across multiple servers and automate your patching system. And that's one of the checks in DBA checks is to make sure you're on the latest build too. So that'll help fix that one up. Now Power BI, refresh. And I'll go check for questions while it's refreshing, as always. INF, I believe they set a command up for INF. I would have to double check, but I believe that's already been set up. Is it possible to run tests where it's not included in the module? Yes, there is ways to write your own custom test and have DBA checks run it for you. There is a blog post for that, I think that Rob Sewell wrote. If you have problems finding it, email me or DM me on Twitter and I will find it for you and send it to you. But you can actually write your own test to be included in DBA checks if they don't have what you want to be checked. And then have it all outputted to the same Power BI report that you're getting everything else outputted to. and he has a tutorial on how to do it and everything. So okay, so we're down to 22 failed. Most of these are auto growth events. Like one did auto grow because it didn't have any space to actually do anything. And then we need to set our auto growth config because it's just set up the percents and the 1 megs. So these are all things that we would have to go back in and fix. But other than that, that is the basics of running everything. And that's pretty much what I wanted to demo. And we will actually see if when our CU is done, we will check the version of SQL Server if you guys hang around for that. I kind of talked fast. Plus, I wanted to leave room for questions. So I talked fast. Hopefully not too fast. This normally takes me an hour, but I did it in 40 minutes. I did good. They only gave us 50 minutes, so. I don't see any more questions. See if our CU is done. Our CU is indeed done. So we can actually check our SQL version now and see that it's not RTM, that is CU8. Go on Azure. Why are you being so slow? And we can see that, well, CU6 is evidently the one I had downloaded. So that's the one it installed. Maybe I misread the 8 because 6 and 8 look awful lot alike. But you can tell it's not RTM because that's where it would have been because I just installed SQL this morning. So that's all I had as far as demos go. Jump back into PowerPoint, which there isn't much left in there. But as far as resources go, the best resources are at DBA Tools for their stuff and DBA Checks. They have a pretty good library. Rob Sewell blogs on DBA Checks a lot because he's the main contributor to it. And DBA Tools keeps a pretty good links of people blogging to stuff on theirs. And it's pretty easy to Google things as well. If you ever come across anything that you don't know how to do, the SQL Community Slack has a very active channels for both of these that people answer questions. If you need me to answer questions, I'm available as well. I do not mind. I answer my emails usually within a day or two. So, or my DMs that quickly as well. So if you have any more questions, I'll let you put them in there. Otherwise, I'm going to say thank you and put up my contact information again, just in case that you guys want to write down something because Bajiano's hard to spell. It is.
That was a great session, Tracy. I loved it,
People can't really pronounce Bajiano, so.
Yeah, so do I. I cannot do it too. So that's why I just use your first name, Tracy.
Yeah,
and we'll have to check out.
Fine.
Yeah, we'll have to check on what Azure is working slow today. So yeah, that's something.
Yeah,
Okay.
I don't know. That server was running much faster earlier today, so.
Yeah.
I don't know what the deal is with it, but now everybody can eat lunch, and I could have I could have went before John and made up for the 7 minutes y'all were running behind.
Oh yeah.
So I ended 7 minutes early.
So it's okay. It's a break. Tracy, Tracy, I think we should definitely get you back. If not for this conference, we do other different live shows at C# Corner, right? There are AMAs and other shows. We definitely want you back in those shows because I think it's going to be really fun having you, right? So just one-to-one, we can talk about things that would be really interesting.
All right, just let me know. I'll be available if you guys are available. So thank you very much.
Yeah, so
I enjoy presenting and helping people learn stuff. So
yeah, great. So thank you so much, Tracy. Thank you so much for your time. And I know it's weekend, but thank you so much for all you do for the community. As I said, we would love to have you back when you're available. I have your email. I'll reach you out. And have a nice weekend. Thank you so much.
All right, you too. Everybody enjoyed the second half of the day.
Yeah, bye-bye.
Bye.
All right, with that, we are now done with the first half of day 2, which means we are now 3/4 of the conference is done, and there's 6 more sessions to go. So in the second half, you're gonna have Mike, who's going to talk about rocket scientist perspective on index column selections, which is pretty interesting. Then we have Hassan, who's going to talk about geospatial data, followed by Frank Gill, Steve Jones, who's from Redgate, who will talk about DevOps with the database, followed by Taob Ali, who's going to talk about Azure SQL database, continuity during disaster, and after that we'll close the conference. So how do you go ahead and join the second part of the conference? In the comments I have given this comment, click on this link, it's in the comments, and this will take you to the second half of day 2, the final part of this 2 days 24 hours SQL Server Virtual Conference. Now I'll see you in 10-15 minutes in that link.